So this week we're actually going to get into the Android component of this course. This week's a little bit packed, fair forewarning, because there's a bit the lessons are the first few lessons are pretty short, but we want to make sure we get them in all this week. So we'll be going over lessons 1.0 and 1.0 today. There's no lab work for 1.0; it's just theory. So we'll cover both of those. And then we'll go over 1.2 on Wednesday, 1.3 on Thursday, and 1.4 on Friday. Any questions so far?
Lesson 1 labs, dude. That's a PDF that we'll just pull down, kind of like we did for the Java.
They're actually available online. We'll go through that right here in a minute as to how to find those and where they are. The hands-on test, if you look at the calendar, is all the way down on February 8th, which will be after we finish all of Unit 1 of this thing. So that's lessons 1, 2, and 3. And that'll give you kind of the basics for building apps. Up until that point, there's really not enough to test you on, per se, because a lot of this is just the fundamentals. Cool?
Yeah.
Okay. So let's get into it. If you pop into Perusal, you should see that there's a few things due this week, and they're kind of spread out to give you an idea of when things should be started and done. So for today, you'll see due date Tuesday, January 19th. You'll see we've got a few documents in here. We've got a few videos, and then there's also this concept skip book. Does everybody see that concept skip book? Pages 1 to 43.
Yep.
Okay. So there's an accompanying theory portion to this course in terms of reading, and that there's basically a chapter for every one of these lessons. So if you pull that up, you'll see kind of what you need to do there. So we're obviously, what lessons are we going through today? We're going through 1.0 and 1.1. So that's the reading that I would expect you to do. You know, for sure today, and then try to get going on 1.2 for tomorrow. Okay, because we'll be going through these pretty quick. So that'll give you the theory portion that goes along with this. This is basically your textbook. So I've spread out the assignments to try and kind of help you, give you some deadlines, which is why you'll see those out there. So for today, pages 1 to 43 is what's due. Tomorrow you'll see it's 44 to 74. So that's lesson 1.2, etc. You'll see there's an assignment due for Thursday and an assignment due for Friday. Along with that, you'll see that there's some videos here, and those are basically the lectures that I'm going to use to give us kind of an intro to it. These were recorded probably, I think, two or 3 years ago now. So they are a little bit dated, and I'll kind of substitute things as we go through because of that. In fact, the labs for this week, 1.0 through 1.4, there's a lot of issues that I had when trying to run them, and I kind of did a finished version of each of those this week. So what I'm planning to do is actually to walk through all of those labs for this week with you because of the number of issues, the number of things that have changed in the past 2 years. Cool?
Yep.
So those lab assignments we will do in class is my plan. They're fairly simple. They kind of tell you how to do the steps. The problem is they tell you how to do the steps, but the steps have changed. So that's why I want to go through them with you. Okay, so if you go to the top and look at course overview, this is the main page of the course that I kind of pulled down to give you a summary. So this is a course that has been built and maintained by Google themselves. So that's the main reason that we're using this. It's kind of probably the most up-to-date thing out there because of that. But again, things have still changed since this was last fully updated. So if you'll notice here, there's a list of kind of course materials that go into this. You'll find that there's code labs, and there's a link here to where to find those. There's a link to the concepts. That's what I've already pulled down and put on Git on Perusal, which we just looked at. You can get to the actual slides here as well if you follow this link. And those are the slides that are going to be used in the presentations. Mind you, there's one issue in that these videos, I believe, were recorded off of version 1 of the course, and those slide decks are for version 2 of the course. So they don't always perfectly align with the video. Fair forewarning. Okay. Next, you'll find that there's a link to the starter code. This starter code is outdated enough that I want you to. I've already gone and updated all the projects to a newer version. So some of these labs will ask you to use a starter app from this project. What I want you to do instead is to use the ones that I'll provide. So if you follow that link, you'll see it brings you to this repository on GitHub, Android Fundamental Starter Apps. Everybody see that?
Yes.
Okay. So what I've done is I've pulled that and I have updated all the projects to be newer. So let me link you. Here is the updated version. So those projects have been all updated to Android Studio 4.4.1. So you should be able to open them directly and without having to go through a lot of upgrade process to get them into the newest version. So anytime the labs ask you to use a starter app code, you're going to pull it from here instead of the place where they point you to. Does that make sense? Agree with that? So you'll need those for a few projects this semester. You'll see that there's just four applications in here: Hello Show Press, Material Me, Phone Number Spinner, and Symbol Calc. Those are the four that are kind of starting points. Okay. So that's what's available there for the different lessons and units. So the way this is broken out, first of all, there's 4 units. Unit 1 will go over just getting started, and that's what we're starting today. Unit 2 will talk about user experience, which mainly is focused around UI and UX type things. The 3rd unit will talk about doing things in the background, which is needed for a lot of things such as working with files or working with the network, working with Bluetooth devices, working with websites and databases, and anything that can potentially take a long time. We want to do that off what we call them UI threads. So that's what we'll talk about in Unit 3. And then finally, Unit 4 goes over how to use settings to persist data long term and to write it to files or work with settings, which is a special Android API. And then there's some discussion on how to use databases finally in Unit 4 as well. So that's kind of the broad overview of the course. As you kind of saw, we'll spend about 3 weeks in Unit 1. We'll go through that pretty quick. The main meat and potatoes of this course that we're going to use is Unit 2. And then we'll skim over, we'll touch on Unit 3s and 4 lightly. I'm not going to cover everything in Unit 3 and Unit 4 because I think we need to spend a little bit more time with databases than they account for, and specifically with Firebase. So that's kind of the gist of it. Most of our time will be in Unit 2 as far as this course is concerned. All right, so Unit 1, we'll kind of go over some basic apps, and most of these will have one screen. Unit 2, you can kind of see an example of one of the things you build there. Is the Material Me application. You've got that, and then you've got that. So as we go through, you'll see that these are you've got units at a larger level, and then beneath that you have individual lessons. Those lessons have 2 numbers, so like 1.0, 1.1. So if you're looking and trying to figure out, how that maps up, I think if I go over to the Git book, I think there's a table on the book that kind of summarizes that up. Or not. So let me go back to the overview then. So on the overview, actually I can go to the code labs. So there's this link to the code labs. Okay, so these are going to be your main lab assignments for the next weeks, is what's here. So you can see Unit 1 is broken up into, basically they say Lesson 1, Lesson 2, Lesson 3. But you'll notice that each of these has a point version. So 1.1, 1.2, 1.3, 1.4, 2.1, etc. So this kind of all comprises that unit. Cool. That's kind of their numbering scheme. And so Unit 2 starts at Lesson 4, goes through Lesson 6, etc. So you can kind of see how that fits in. Any questions so far on just course structure? Okay, so one thing to call attention here, there's nothing really you need to comment. This is but this is the kind of the release notes for this version of the course. So there was originally a original release of this course. This is version 2 of the course. When they went from version 1 to version 2, they did change some of the numbering, so where things are at. The reason that this might be relevant is because the videos, as I said, were recorded against version 1. Everything else is against version 2. So you may see some discrepancies there. Troy, are you trying to say anything? Because you're not coming through. Your mic is not working. So that may help if there's kind of questions about it. And one of the big things in there they mention as the first item is this idea of a constraint layout, which is a relatively new concept. There's also something new called Android X or Jetpack, which we'll go through, which is newer than has been released in the last 2 years. Okay, so let's get into the video. All right, I'm going to do a sound. Start this. Can you hear the audio?
Yes.
Yeah, we can hear it.
Good.
Yes.
Good. All right. So let's get...
Hello, I'm Jocelyn Becker from the Google Developer Training Team. My team's created this course called Android Developer Fundamentals. We made this course to help you learn how to build Android applications. Companies everywhere, from tiny startups to multinational corporations, are hiring Android developers. This course will get you on the road to becoming an Android developer. As you work through the course, you'll learn how to build Android apps, starting with the very simple Hello World app, all the way to building an app that can share data with other apps. This course gives you lots of practical experience, and you'll build lots of different apps as you progress through the lessons. Each lesson includes a lecture. After taking the lecture, you can read the textbook and then work through the practical exercises. Some lectures don't have practical exercises, but most of them do. This course is intended to be taught by teachers in the classroom with students coming to class. We're offering videos of all the lectures in case the teachers or the students want to review the material in the comfort of their own browser. And with that, allow me to introduce my colleagues who will be your trainers in the following video course. This is Lalit Singh. He's been teaching Android development all over the world.
Thanks, Jocelyn. Hi, I'm Lalit, one of the trainers for this course. I warmly welcome you all in this Android Developer Fundamental course.
And this is Sylvia Nand, and she's been teaching Java courses.
Thank you, Jocelyn. Hi, I'm Simi. I'm also one of the trainers for this course and welcome you to have a great experience on developing the Android apps.
First things first, the lessons in Unit 1 cover the basics. By the end of the lessons in the first unit, you'll have built apps with multiple screens that respond to clicks from users. Come on then, let's get started building Android apps.
Cool. If you want to design app. Hello everyone, I'm Lalit Singh. I welcome you all in this Android Development Fundamentals. In this course, you are going to learn about Android application development from very scratch. This particular slide deck contains the introduction to Android. This will tell you about Android ecosystem, the Android platform architecture, Android versions, challenges which we face in Android application development, and the basic building blocks of Android itself. First of all, let's just talk about what exactly is Android. Well, Android is operating system. You guessed it right. But is that all it is? It is actually a stack-based Linux kernel. Under the hood, there is a Linux kernel. What exactly is kernel? We all know. It acts as an interface between your hardware and your software. So here we are using Linux kernel, not Mac, not Windows, as Android is an open source environment or open source ecosystem. What are other things? Like you can have a cool user interface like touch screens, sensors, and we all know Android is covering more than 80% market right now when it comes to smartphones. And we have different ways to connect your Android now, not just at smartphones. We have cool Android watches, or we call it Android Wears, TVs, and Android Auto also in your cars and vehicles. And there are more than 2 million Android apps in the Google Apps Play Store now. The cool thing, the best thing which developers gonna like is Android is highly customizable. So if you have a particular device, you can mold your Android according to your own will. So when it comes to user interaction, what are the different user interaction? You can swipe, you can tap, you can pinch, zoom in, zoom out, and we have a virtual keyboard here, which gives you pretty much cool features like numbers, typing numbers, character, emojis, all those cool faces you see, you get it from your virtual keyboard, and support to high-tech hardwares like Bluetooth, USB controllers, Wi-Fi adapters and all. So all these things, all these cool things you can attach and you can work around with your Android device. So Android, when we talk about Android sensors and all, how exactly those sensors are connected? We have sensors like proximity sensors, accelerometer sensors. So all these sensors work, you must have seen when you rotate your device, in your games and all, when you rotate your device, your object, your player rotates. How exactly that is happening? Because there are sensors already placed inside your Android device, and your Android operating system help that device or help that sensor to connect with your own application. So we can position into a map on a particular location, and we can do the navigation, and we can even steer a virtual car or a toy. So all these things can be done with the help of your Android operating system. So when we talk about Android, we always see that home screen. Okay, that home screen is what? That home screen is itself an application which can actually contain other application, right? We see icons there, launcher icons, app, self-updating widgets are there, multiple pages are there. We even see that OK Google. So all these things are nothing but your whatever you see on your screen are your home screen itself is an application, and your home screen is known as an activity, which we are going to discuss in further chapters, what exactly an activity. But for now, understand that the screen itself is actually a part of your application itself. If I have to give you some examples, you must have came across these pretty famous applications: Pandora, a great music player, and Pokemon Go, which is in a great hype right now, right? And Facebook Messenger. So you can build all these cool apps once you learn about how exactly, or the basic mechanism of Android itself. So you can build all these apps. So what exactly, or how exactly you are going to develop your Android applications? To do that, you need Android SDK. Android SDK is known as Software Development Kit. This is specifically for Android application developers, and for that, the prerequisite are Java. We are going to go through all the prerequisites which you need for that in a bit. But as of right now, let me tell you what exactly are the different tools which you will be getting here. You will be getting development tools like debugger, monitors, editors. There will be libraries here, libraries for your variables, maps, and there will be the documentation. If you need any help, we have the documentation, everything charted down in your developers.android.com, and there will be sample codes also. And the best thing or cool thing about when we are developing Android application development is you get emulators, virtual device. So you don't even need to get a real device for the testing purpose. You get a virtual device. Anything you want to develop, any application you develop, you can test it in your virtual device, which will give you exactly the feel of a real device. So when we talk about Android Studio, this is how your Android Studio looks like. Most of you are already familiar with Eclipse or any other IDE, so there is not much change. But when we install our Android Studio, and when we get to that Android Studio IDE, we will talk more about it. But let me tell you what exactly Android Studio beforehand provides you. It provides you an environment where you can develop. It provides you with your running features and debugging your app, right? Testing and all the packages inbuilt. You can monitor your performance. You can monitor your memory usage and all those things, and the virtual device itself, which I just talked about. All those emulators, whether it is running in Android 6.0 or 5.0, you can get them and with the help of your Android device. You have different views, or if I should call it, we call it project hierarchy also. So you can always go through different ways of viewing your whole project. So we will go through that also when we see the whole Android Studio in action. And we have a visual editor. So you don't have to worry about, do I need to learn the coding specifically for designing a UI? No, that has been taken care for you by visual editor, or you can say the visual layout editor. So you just have to drag and drop. You need to know what you really need to, what you really want to design, and that's it. There are views for you. There are layouts for you. You just have to drag and drop. So this is Google Play Store. So like I said, there you need to create an account which worth $25 lifetime, which will give you access of official Play Store, or you can say a market where you can publish your app. And Google Play Store is an official market where you can publish all your apps, and it will be provided all over the world. People can see, right? And that's where you will be publishing all your application. See, there are ways you can get this application to the people by providing them with mail and providing them with USB drives and all, but it won't cover the whole market. So we have this market here specifically for publishing your app all over at the majority or large scale. So before we get more into Android, we need to know what exactly or how exactly your Android has been, what is the internal structure or the architecture of Android. Let's just understand what exactly Android looks like from inside. If you remember, I told you in the starting only, Android is a stack-based operating system. So what did I meant by that? So stack-based means it is layer upon layer. So the stacks are so the layers are stacked like layer upon layer. So when we talk about stack-based, at the very bottom we have Linux kernel, then we have HAL, hardware abstraction layer, then above that we have a layer which contains two things, that is native C and C++ library and Android runtime, and then we have Java API framework, and above that we have system apps or user apps. So let's just go through with them each one of them very briefly. So see here, when we talk about system apps or user apps, these are the apps which comes with your application inbuilt. System apps are inbuilt application, like your call application, your SMS application, or your Google Chrome application, right? So all those apps which comes within your device when you purchase your device for the very first time, those are known as system apps. User apps, which you install separately from your Google Play Store. For example, WhatsApp, for example, Facebook, for example, any game which you are installing from your Google Play Store, or you can develop your own app and install it in your device also. So those are known as user apps. Good. So next is Java API framework. So this is the API which we Android developers will be working vigorously, because all the APIs which we need for our application development is inside this Java API framework. This is also known as Android SDK. So all those developers which work in this layer are also known as SDK developers, Android SDK developers. So if you want to design an application, you will make use of all these classes. So we have view classes here for designing your layouts in Android. Any UI you see, any layout of any application you see, it has been designed from this particular API. You have notification manager. All the notification which you see, all cool notification when you while you are using your social applications and all, they are being designed from this API only. Your activity manager, all the screens itself are being designed from this. Content providers, sharing of data, again from this. So there are a lot more classes which are there in Java API, and we are going to make use of all these classes when we go and start making our applications. Okay, next is our Android runtime. What exactly is Android runtime? Well, this is where all our application runs, right? So inside your Android runtime, there are compilers like DVM or ART. Well, all the new devices now use ART. Before Android 4.4, we used to have DVM, but ART was introduced in 4.4, and now all the higher version you will see, Android 7.0, 6.0, they are using ART. Right, so we will talk about ART also when we get into our actual difference between your Gradle build system and Eclipse build system. So just know for now, Android runtime is the place where all your application come and run. C and C++ library are also known as native libraries. This is the section where all your system libraries are being placed, and they are written in C and C++. Now, we have developers for this particular libraries also, but they are known as NDK developers, Android NDK developers, known as native development kit developers. Now, as for this course, we will be working on SDK developers, but there are developers which work on directly C and C++. Now, what exactly the C and C++ library contain? This will contain all your high-end libraries like graphic libraries, OpenGL ES, your secured socket layer, SSL, and your WebKit OS. So all those libraries which are very hard to write in your Java and easy to write in C and C++, you will be using inside C and C++ or native library section. Next is hardware abstraction layer. Now this layer has been particularly written or particularly charted down to access your hardware from your application itself. So there are predefined methods which are there to use, or which are provided to you to access. For example, if you want to use camera application, or if you want to open up a camera or Bluetooth or Wi-Fi, there is already hardware abstraction layer methods, predefined methods which are defined in hardware abstraction layer. You just have to use those methods in your application, and you will get the access of your camera. So next is our Linux kernel. Now Linux kernel act as any kernel which you see in any other operating system. It handles your threading, it handles all your low-level memory management, it handles your resource management, it handles all your security features, and it also includes the drivers. Like if somebody wants to call camera application, he has to first go to HAL, like we discussed. Then HAL will in turn will go to the drivers which are written in your Linux kernel, which are there in your Linux kernel, and it will give you the access of your actual camera hardware. So and the Linux kernel has the supreme right in Android application development. For example, let's say if you see whenever you see that there is your application is getting stuck, or application is not responding, you must have seen you must have seen a dialog box appearing up right away, and it is saying application not responding. So who is actually popping up that dialog box is actually Linux kernel. At any point of time, Linux kernel sees that your any application is taking too much resources and is not allowing any other application to run freely. So Linux kernel have the right to kill that application. Of course, it will ask you in the starting that this particular application is taking this much space or this much memory, and if you want to wait for this application to respond or not. But if it really goes, if the memory really goes out of if that application takes too much memory and it really goes out of the memory, and then your Linux kernel has the right to restart your device itself. So next, you see all these cool Android versions. Well, Android starts from Android 1.0, but all these fun versions you can see all here that which have code names. The latest one you see is Nugget, and there is a very interesting thing here which we will see, that each code name or each Android version name start with an alphabetical order: H, I, J. So and each code name is a desert name. And the one more thing which I really want to discuss here is API level. So each version is working on a particular API level, and API level are application programming interfaces. So there are a set of classes which are being provided at each Android version, which you will be using to develop your Android application at that particular or for that particular version. Like if I want to develop an application for KitKat, I will be using the API 19 to 20. And if I'm developing for my latest version, so it will be API level 24. Well, when I want to develop an application, I really want to keep this in mind, that there is always a maximum level of API, that is the latest one, so that all the new users can make use of my application. Plus, I also want to set a minimum version of Android, so that even the users who doesn't have the latest API right now or version right now in their device, they can also still use it. Right. So we will talk about it more when we start making our application. We will set a minimum version there, and we will set a maximum version there, and you will see that in your application itself. Now, how exactly application development goes here? Well, first thing first, Android is not just one screen. There are so many screens which you see. You click on one screen, you get to next screen. So we will see all those, how exactly we how exactly we design one screen, how exactly we go to next screen. But what exactly we use under the hood? We use Java programming. That's right, Java programming plus XML. But don't worry about XML. We don't have to be an expert on XML, but yeah, you do need to know how exactly we use XML to design our layouts. So now there will be a complete go through for this XML part also when we will be doing our UI design. And of course, you will be needing your Android SDK, that is your software development kit, and the Android libraries. Now these libraries gives you some extra feature which you are not having as of right now in your SDK. So this particular libraries will give you for example, the material design. Material design is the newest addition in your Android 5.0, and if you want to make use of your material design in the versions below your 5.0, you won't have the access. For that purpose, we have Android libraries, or to be more precise, we have app compact libraries for that, which will give you the access of that particular material design feature even in your lower versions. So we'll talk more about it when we get into the development part. And we have an Android runtime virtual machine here, or you can say ART, which has been, your runtime machine is executed at their ART, which will be very helpful when you are running or testing your application. So what are the challenges you face when you are doing your application development? Well, most of it you are going to face that you are designing for a particular screen, and that UI is whatever you have designed for that particular screen is not looking the same in that different screen resolution or different screen size. So we have a way to fix that also. And the performance. Most of the time, if your app is using all those classes which are using extensive use of graphics, networking, and internet and all, there might be a chance that your application is taking long to open, especially in the case where your device is not high-tech device, your processor of the device is not that much powerful. So you will face the challenge at the performance level also. So you can always rectify those performance errors, and you can make your application faster. That also you will see in best practices of performance. Security, you can always keep more security or encrypt your application whenever with the ProGuard files which you have in your Gradle in your Android application development, now in your application itself. So you can always make your application more secure with your ProGuard files. Compatibility. Now that's an issue or challenge which you will be facing a lot. That's because you will be targeting for a particular version, or you will be targeting a majority of people. That's what our aim is, so that whenever we develop an application that can be used by a majority of people. But we cannot expect our application to run in each and every version. Like let's say I want to create an application which will run in 2.3 also, but if I'm going all the way down to 2.3, I might have to sacrifice with many features which I really want to add in my Android application development, which will give a real look and feel to my Android application development. But that's not going to happen because you are going all the way down to your older version of 2.3. So we have to make a balance here. We have to target, or we have to put a minimum Android version for our application development, so that I can cover majority of people. So for example, right now, most of the people over the world, you can see that they are at least using ice cream sandwich. There will be very less percentage of people who will be using 2.3. So we are going to skip that particular mob, and we are going to target our application development to 4.0 and above. So this will give us a complete majority of people which we really want to target. Next, marketing. Now, marketing, of course, it's totally it's upon your it's upon you that how exactly you want to market. Marketing can be expensive if you want to put that all the advertisement all over the place. It can be expensive also, but it can be cheap also. I mean, you can just add mobs. There are libraries for that also. You can add those, but it all depends upon how well you want to market your application. So those are few challenges which you will be facing when you will be creating any application. So we will address those challenges also. So when we talk about Android building blocks, so what are those building blocks? Android is not all about Java. I mean, Java is one thing you will be doing. You will be putting all the functionality with the coding part as a Java language, but it's not all about Java. There are UIs, there is layouts, there are images, there are XML files. So all these things are known as resources. So resources will be there along the way to help you out to design your application. Plus there will be components, activities, services, helper classes, model classes, and the manifest file. Now, manifest file is one of the most important file in your Android application development. It is the very first file which your Android device sees whenever you download an application. It gives you the information about your application itself, what your application contains, how many screens it contains, what are the services it contains. So all the information is being written in your manifest file. It's kind of a configuration file which you see in your any other application. The next thing which you really want to look at is your APK. Now this is the end product which you get whenever you are developing, we are done with your application development. So this APK file is the one which you will be uploading to your Google Play Store, and this is the file which everyone out there will be downloading, and this is your application as the whole. So next, components of Android. Now whatever you see, all those applications out there, they are built with these 4 components only. Nothing is outside these components in the Android. So first is activity. What is an activity? Activity is anything which you see on your screen. Even your lock screen is an activity. Your home application, you see the very first home screen is an activity. So anything which you can see on your screen and a user can interact with it is an activity. Services. Services doesn't have UI, unlike your activity. They run in the background. For example, your music player. You play your music and your music start playing, and now you can switch to other applications, and still your music is playing in the background. So where exactly your music is being played? In the service. So a service doesn't need a UI, unlike your activity. So it runs in the background. Content provider. In Android, 2 applications cannot share data because of the Linux kernel, which provides you a sandbox model under the hood. So how can you do that? How can you share the data? Well, that's when content provider comes in. Content providers are the mechanism, or you can say classes, which help you share data between 2 applications. Broadcast receivers. Broadcast receivers are the classes which listens for a particular set of messages. For example, if somebody sends you a message over WhatsApp or any other application, now there will be a broadcast receiver contained in that application who will listen for that particular message. Well, the message is being transmitted to the entire device, but only WhatsApp application is the one who will pick that up, but other applications broadcast receiver will ignore that particular message. So you can think Android as a hotel. Your app is your guest. Your Android system is your hotel manager. Now there are certain services which you request. You can invoke them with the help of intents, which we are going to go through in further slides. Now there are services which requires your presence. For example, let's say you want to register for your hotel registration. So that requires your presence. So that's what an activity is, like your UI. Or there are services which doesn't require your presence. For example, laundry. So that you can compare with your services. Now you get a call that your package has arrived. Now that's you can compare with your broadcast receiver, and you get the access of the city map. All these access which you are getting, you can correlate with the content providers. Here are the few more links to give you extra information regarding whatever we have covered. We're gonna go more deeper together in further slides. So next, we're gonna cover introduction to development in the Android.
All right, so there's your kind of first introduction to some of the theory and concepts of that. So just a reminder, what are some of those components that he mentioned in that video? What are some of those major components of Android?
You mean
The
stuff like
broadcast
activities?
receiver.
Broadcast receiver was on. Yep. What else?
System.
Okay. Troy, I think were you trying to say something? Okay, I heard 2 people come. Somebody else. Services, so broadcast receivers,
Content provider.
content providers, activities. Okay, of those, what is the one that runs in the foreground?
Activity.
Activities. So we're going to be spending most of our time here with activities. So lessons, but all of Unit 1 and Unit 2 are chiefly focused around activities. We'll get into services and broadcast receivers up into, that'll be Unit 3 is when we hit those. But for the most part, we'll spend the next basically 7 weeks ish working with just activities because they're the fundamental part of your UI. Now, one thing to clarify: an activity is a screen. It's specifically a screen. The other elements, the controls that you see on that screen. So if you're thinking about like an input field, text box, button, things like that, those are what's referred to as views. So a view is a individual control on a screen. Does that make sense? So activity will contain a hierarchy of views. And so the views is what you're mostly going to code a lot of your UI logic is going to be against views. Okay. So what are some of the challenges that he mentioned that you might want to keep track of as you're building Android apps? There's a slide about that.
I remember
Well,
something about versions and
Mhm.
being backward compatibility.
That's one part. Yep. Backward compatibility is one of the issues.
multiple screen sizes.
Yep, that's one part, right? And where might that come in?
When you're designing a UI.
Mm-hmm. You have to think about your designing UI for a broad range of devices. So you might be designing your application to work with, say, 10-inch tablets, 8-inch tablets, 7-inch tablets, all the way on down to even 4-inch phones, or even smaller than that, you've got smartphones, smartwatches that you might be designing your application for. So that broad range of devices and screen sizes can be a real challenge, and you have to think about that as you're building your application. Remember, one of the things that we've talked about in the web development world, is that usually you want to do mobile first design, right? That's how we usually talk about it in the web design world. You remember that? What does that mean? To do mobile first design.
Design for the smaller screen first.
Mm-hmm. So in web design, the general consensus is always designed for the smallest screen first. But why is that? Why would you want to design for the smallest screen first?
Is it easier to expand pixels than it is to decrease them?
Yeah, it's usually easier to make your layout use up more space rather than figuring out how to make it take up less space. So it's easy to, if you start with a UI that kind of can work on the smallest devices, it automatically inherently works usually good enough on anything bigger. Does that make sense? So typically when we start designing our apps, we want to do that kind of same approach where we want to start designing to the lowest, lower end and the smaller devices first. You don't want to start with the biggest 10-inch tablet and then work your way down because you'll find that it doesn't work at all on the 4-inch tablet, 4-inch phones. Does that make sense? So what we're going to do, anytime you're making your app, you want to start and test it on that smallest device, and then we're going to kind of scale it up. So your baseline for this is going to be a 4-inch device. The Nexus S is generally that low end device that I target. So the Nexus S is one of the smaller screen sizes. So we target that, and then we'll build our way up until about 10-inch tablets are about the biggest that's available on the market. Does that make sense? The other thing you have to consider is something called not just the screen size, but the resolution. So there are a lot of phones, a lot of smartphones that are 4 or 5 inches in their screen size, but they have 1080p pixels, like they're 1920 by 1080. They're the same number of pixels as you have on your laptop screen in a 4 or 5 inch screen. So how do you rectify that? Well, because there's this idea of resolution, or dots per inch or pixels per inch. How many pixels are there in that 1 square inch of space? A lot of smartphones, there's a lot more screen density than there are on, say, your laptop screens. Does that make sense? More pixels in a smaller space.
Yep.
So that means when you're dealing with mobile apps, you have to think about that DPI, the screen resolution, is really, really important. And what that does mean is for instance, you may need to have different image resources for devices that are even the same size. So let's say I have one device that's 5 inches, 5 inches in size, but it's a 640 by 480 screen, versus I have another device that's 5 inches in screen size, but it's 1920 by 1080, and that does actually exist in the market. Do you think you need to use different images for those two devices? Yeah, probably, right? If I were to use the same device, if I were to use the same image for the small devices as I use for the large device, you're going to find that your edges, and in general, your image is very blurry, because of that difference in screen resolution. So we need devices, we need images that also have a different resolution, and that's one of the things that we have to pay attention to, in addition to other things. Cool. So screen resolution is a big deal beyond just screen size, and a lot of people forget to think about screen resolution when they're building apps, and just focus on the screen size instead of focusing on both. One of the things that I will mention here, you remember that he mentioned in the video that there are emulators that are available in Android Studio, which can kind of be a virtual device. But you also remember that I've given you all a physical tablet, right? So one of the reasons and one of the things to pay attention to there, those emulators do not properly represent screen resolutions. They generally don't properly represent the density of the pixels. So oftentimes your application can look different from the emulator to the physical device simply because of screen resolution differences. Everybody with me on that?
Yeah.
So do make sure that you actually test your apps on physical devices, because there are some things like that you really can't see with just using an emulator. So that's why you have those. The emulators take a good amount of resources. So having a physical device does mean that your laptop doesn't have to work as hard. Okay, so performance is an issue. Remember that a lot of smartphones and tablets have a slower processor or less memory in general than your actual laptop does. So you do have to pay attention to a little bit of that, because there's just fewer resources available. So you have to use them sparingly. security is a definitely a really important thing in growing and growing. So that's another thing we have to talk about and think about. We won't do too much with security here in terms of keeping source code safe. He did mention there's something called program, and that's something you get into when you want to put your app on your Play Store. The other side of that, though, and usually the more important one, is how do you keep the data safe? Not as much the code, but how do you keep the data safe? And that means a lot of things. Sometimes it means putting things on the app, on the device in secure places, or not storing them on the device at all. But a lot of the security in terms of user data, a lot of that is dealt with on, say, the server side. Say you have like we built Node apps last semester, a lot of that security would be dealt on the server side where the database is. So that's important, but we won't get into much of security because a lot of it's not necessarily on the Android side. Some of it is. Compatibility, as you mentioned, is a big deal. Remember, we're going to have a minimum API and a maximum API. That's what we're targeting. Does anybody remember what those version numbers are? I mentioned this first week class.
21 through 29.
21 through 29. Okay.
I thought it was 19 through 29, but never mind.
It's 21 through 29. This course, being a little bit older, I think it only covers 15 through 27 is the way they target their app. So that's one of the reasons I went through and modified those starter apps, and also why we'll go through, doing the labs this week, because that does affect things. Yeah, and marketing is really beyond the scope of this, but it is an issue with the sheer number of apps on the marketplace. It can be hard for your app to get noticed or discovered. So that is an issue because there just are so many apps on the Play Store. Okay, that's the main thing I wanted you to refresh on here, is that slide, the challenges, as well as talking quickly about the components. So let's move on to 1.1, and that'll talk a little bit about how do we put this into use. Any questions before we get to the next part? Okay. I'm going to go ahead and start this. I guess one question I should ask is, do we want to do a break now, or do you want to do it after this video?
How long is the video?
So this video is about 18 minutes long.
Let's do it after.
After.
All right, so we'll do break after this.
Okay, now you have seen what exactly is Android. So now it's time to create your very first app in Android. In this particular slide, we are going to cover about Android Studio, create our very first Hello World app, and we're going to understand the basic app development workflow in Android Studio also, and then run our app in virtual device and even in physical device. Okay, so the prerequisite for Android application development would be Java programming language, and you need to have a good idea about object-oriented programming, and the XML, how exactly you put properties and attribute in XMLs. And you need to have a good idea of an IDE, a prior IDE, doesn't really matter, an IDE which you have used in past, and we will see how exactly we work around with our Android Studio. So your Android Studio will look like this, and it will contain many tools like debuggers, Logcat, monitors, emulators. So we're going to look at each one of them in coming slides. First of all, we need to learn how exactly we can install Android Studio in our machine. So first, we need to download JDK. So we will go to our browser and type download JDK and download the latest one, JDK 8. And this will take you to Oracle website and accept the license agreement and download it for whatever the machine you are working with. for me it's Mac, so I will download that. Once your JDK is downloaded, install your JDK. Install your JDK and continue install.
Yeah, why is he using Mac?
Don't ask me.
Steps in Windows will be pretty much same, and you have to once the JDK is installed, now next you can go through install or downloading your Android Studio. So just type download.
We've done this
Android
part already,
Studio.
the JDK and the Android Studio, so you should already have all
And
that installed.
just click on the link. It will take you to the developer website, and from here you can download the Android Studio. Now it will identify automatically in which machine you are working, and it will give you if it is you are working with Mac, it will give you Android Studio of Mac version. If you are downloading or if you are working with Windows, it will give you Android Studio with Windows version, or the same goes with Linux. So download the Android Studio, accept the license and download it. Once your Android Studio is downloaded, you can start installing your Android Studio. In Mac, you can just drag and drop in application folder. In Windows, you will just double click your Android Studio and it will get you to a Windows, and from there you just have to follow the instruction and press next and install, and then
Am I the only one that
here,
can't
you
hear
will see
this?
Android
Or?
Studio here. Press on Android Studio,
He's talking pretty quiet at the moment,
click on Android Studio and open.
so you might need to adjust your volume.
It's max right now.
Now, for the very first time, it will ask you for installation of SDK. By default, it always installs the latest SDK. Where exactly you want to install your SDK, so this will be the path. You just click on next and finish. So once the latest component has been downloaded, you press finish and you will get to the screen. Now, from here on, before right away getting into creating a new project, you click on configure and click on SDK manager. What exactly we are doing here is we are installing further SDKs which we will be needing while we are developing our Android applications. So either you can install SDKs from here, just click on Android 7.1, whichever version you want, just click on that and press OK, or you can always go on launch standalone SDK. Launch standalone SDK will give you more freedom to install your Android versions. For example, in your Android 7.1.1 API 25,
It's worth noting, so there's some components in each of those API levels that you can choose to uninstall and uninstall, install or not. You see the little checkbox here, show package details. That's still available in current versions of Android Studio. That's all you have to click to see these subparts. So say you don't want to include the sources or different images for a package, you can uncheck those as long as you hit show package details here. So typically you don't need to get into this window. This window is part of what Google actually ships as their SDK, but typically you don't need to interact with this window directly.
Okay,
You
I got a
don't
quick
really-
question. After today, are we done with IntelliJ?
Yes. Yes.
Oh,
entirely
no,
in
I
Android
just got
Studio.
used to it. What a shame. Okay.
Well, the good news is Android Studio underneath it, and I mentioned this before, is IntelliJ. It's a different version of IntelliJ. So a lot of things that you learned and figured out how to use with IntelliJ will transfer over to Android Studio, but the configuration doesn't. So just a reminder, any of those things that you set up for code formatting that I asked you to do, remember you'll need to do those in Android Studio as well.
All right.
Need a system image of Android TV, because we are not gonna design, or this development is not going to be for your Android TV. We might need Google API Intel x86 Atom 64 system image. So if I'm using 64, so I don't need x86. So you see, you have you can select whatever you want to download and whatever you don't want to download. So this is for your latest. If you want to work with other versions also, you just have to go inside those version. You just have to click those version and select whatever you want to download inside those version. Like in Android 6.0, you definitely want SDK platform. You don't want TV. You don't want ear system images also. You don't want Android Wear system images also. Then you don't want ARM system image also. Now ARM is again a system image, or it gives you an emulator which can run your application, but ARM machines are slower. So that's why we need Intel machines, which are pretty faster as compared to ARM. Now in that context also, I could have chosen Intel normal machine, but I will be choosing Google API's Intel machine here, maybe 64-bit or 32-bit according to your system configuration. Why Google API's Intel machine? Because it gives you all the feature which you have in your normal Intel machine, plus it always provides you with more freedom to use your Google APIs also. So if you are using a Google API Intel machine, then you might have to download Google APIs also, and then you definitely need the source code for your Android SDK. Now this is for one of the stable version in the higher one, but if you want a minimum version also, like we will be working with one of the minimum version with API 15, you are free to select whichever version you want as your minimum version. You can go ahead and install stuff from that particular version also. Like we need SDK platform, we are not going to work with ARM, and here also we will be working with Google API Intel x86 machine and Google APIs and source code for SDK. Now like I said before, you can download ARM and other machines, but it's of no use because we won't be using them. We want our application to be running in a pretty faster manner. So for that purpose, we need Intel machines and with the Google APIs in them. After that, just go to the bottom, just come to the extra sections. In that extra section, you will require Google Play services if you want to use any Google APIs like Maps and Maps or billing system of Google APIs. And then for Windows, you might require Intel x86 emulator accelerator to run your Intel machine in your Windows phone. And then you can just click on install packages, accept the license, and accept the license for other options also, and click on install. And this will start installing your other Android SDK. So now you have seen how to install the Android Studio. So let's just learn how to create your very first application, Hello World application. This will be the very first screen you will be seeing, and you can create a new project by clicking on the very first option, start a new Android project. Or you can always create a new project from inside the Android Studio. You will get transferred to this screen, and this is where you put the name of your application, what you want to name your application, and the project location, where exactly you want your application to be saved. After that, you will get transferred to the different templates. From out of those different templates, we will select empty template as we want to start from the very scratch. Next, we will give the name to our activity. Like I said before, activity is a screen, and we want to create our very first screen for the application. And activity is not just a Java code, so it contains the UI part also. So it will have a Java file plus a XML file also, which will contain its UI part. So we will name Java file as main activity and XML file as activity_main. So this is how your Android Studio will appear at the very starting. As you can see, on your left is your project files. So this is from this pane, you can navigate through your project. You can click on any one of these files and you can open those files. In the middle, you have layout editor or code area, where you can either create your layout, UIs, drag and drop, or you will be writing your code in this middle area. At the bottom is known as console area, where you will see the status reports or logcads, log messages of your application or the application you are creating. When we talk about project folders, there will be 4 folders. First will be manifest folder, which will contain a manifest file, which will give you the information about the application itself. Next will be Java, which will contain all your Java code. Next will be res, which will contain all your resources. It can be a layout, it can be a string, it can be images, it can be audio files. So all those resources will be kept inside your res folder. Last will be build.gradle files. So build.gradle file will give you the information about building your project, an app, and module. We will see about this in further slides. So when we talk about Gradle, Gradle is a building tool used by your Android Studio. And there are basically 3 types of Gradle files. First, project level Gradle file, module level Gradle file, and setting Gradle file. What exactly project level Gradle file contains? Project level Gradle file will contain the information about the Gradle itself. What is the version of Gradle you are using, and what kind of repositories you are using inside your application. So there will be one project Gradle file per application. Next will be module Gradle file. Now there can be one module Gradle file or more than one module Gradle file. Now it depends upon the number of modules you are making for your application. Now if you are creating an app, let's say weather application for mobile also, for VR also, and for TV also, now there will be 3 module Gradle file giving the information about each module. Each module Gradle file give you the information about each module, like in which version you are creating that particular module, what is the minimum version, what is the maximum version, what is the application ID, or what are all the dependencies. So that will give you the information about the module level Gradle file. Last is known as setting Gradle file. Setting Gradle file give you the information about which module you want to include for your compilation. So if you just want to compile your mobile module, then you will just include mobile module inside the Gradle file. If you want to compile mobile plus TV, then you will include mobile module plus TV module. For more information, you can follow the link about the Gradle. Now, once you have created, once you have followed all these steps, there will be a default app for you, Hello World. So how do you run that application? There is always, so how do you run that application? There is a run button at the top. You click on that run button and it will ask you for a virtual device. So you can always create a virtual device. There will be a button, create new virtual device, or you can either go to your Android AVD manager, that is Android Virtual Device Manager. From there, you can choose the hardware, which hardware you want to use and for which resolution you want to create an emulator, either Nexus 4, Nexus 5, and then click on one of the hardware or resolution, click on next, and then you can choose which version you want to install in that particular hardware, Android 7.0 and Android 6.0. Now please be apprised that whichsoever SDK you downloaded at the time of installation, only those system images will come here. So whatsoever system images you downloaded at the time of SDK installation, only those system images will come inside this, and you can use one of those system image here. And then you can give the name to your Android virtual device and then click finish. And it will give you your Android emulator, and this is how your Android emulator looks like. You can always make your real device also as a testing device. For that to happen, you have to make your real device a developer device, or you have to turn on your device in developer mode. How do you do that? Go to settings, click on about phone, and inside that there will be build number. Now tap into the build number 7 times. Yeah, 7 times. And then you will see that the developer option, which was hidden before into the settings, is available now. Now go inside the developer option and turn on your USB debugging mode, and there you go. Your device is now a developer device. Now, this is the first part. If you are using Mac, this is all you have to do. Now you have to connect your USB cable to your machine, and you will be able to run your applications. But if you're not using Mac, but if you are using Windows or Linux machines, then you might have to download USB drivers for that particular device also and install that in your machine. And after that, you connect to the USB cables and you will be able to run your application in your real device also. As your app runs and you want to get the feedback, you want to see what exactly is going inside your app. So for that purpose, we have a logcat tool which is inside your Android monitor. Whenever you will be running your app, you will see this all the logs inside your logcat popping up. So this will keep track of whatever is going inside your emulator or your Android device. So this is how you put a log.d for debug mode, give a tag and give the message. We'll learn about logging in detail in further slides. So this is how your logcat pane looks like. So you can see you have to enter a log statement inside your Java code, and then at the bottom you will see inside the Android monitor there is a logcat pane, and that's where you can see whatever the log statement you have put inside your Java code. To learn more, you can follow these links about the creating and managing Android Virtual Studio and different platform versions. So next you can follow the concept in Git book exercise 1.1, and then we are going to go through with the practicals of creating your very first Hello World app and run it into the emulator.
Okay. So that's the theory portion of it for today. So let's take a break, and then when we come back, we'll jump in and make our first applications. So let's see. Let's say 15-minute break and come back at 2 o'clock.
You mean 10 after 2?
Right. Yes, 10 after 2.
Okay.
Mr. Smith, question.
Yes.
What is going to be your commit today?
What is going to be your commit today? That'll be the code lab.
Oh, the code labs? Okay, yeah, because you extended the date to Friday, didn't you?
No, you've got a new assignment for this week.
Oh, okay.
Hey Sheridan, I think your push to talk key's stuck on. How was everybody's weekend? Okay, everybody back? Am I sitting in this room alone? Mo, are you back?
Can you hear me?
I can hear you.
Yeah, I'm back.
Okay. Half the people are here and getting a response. Like, am I here by myself?
Wow, this is so weird. If you pop out the screen on Discord, your Discord ends up eating up a gigabyte of your RAM.
Hmm.
Yeah, it looks like we're gonna unpop that. Oh, there it goes. It's all down.
So let's get back to going. So we kind of got your theory intro there. So next thing we want to do is actually start building our first Android application. So if you're looking at inside Ranken, remember that this week we're going through 1.0 through lesson 1.0 through 1.4. So that'll be all in lesson 1, and that you can see a few different assignments there because of that for this week. Next week we'll be covering lesson 2. So those are the things you want to pay attention to. So if you're looking at your assignments for perusal, you'll see that there's some expected comments and discussion on the videos for this week for 1.0 through 1.4, as well as the expected discussion on the reading material as well, which you can see as pages 1 through 43, etc. So that's what that is. The code labs, which is what we're going to start here in the moment. You'll notice that there's 4 code labs. One we'll do today, Wednesday, Thursday, and Friday. So those are each worth, and this is actually wrong because that should say 5 points.
Are we doing them all together?
Yes, we'll be doing these together this week.
Okay.
Let me fix that. There. Actually, that should be saying. There we go. That's what it should say. Yeah. So for your new repo, remember that you already created one last week for Unit 0. So you'll want to create a new repo for Unit 1. So over on the GitHub Classroom world, I've already created those assignments here. So I'll give those out as we get to them. So I've got one already set up for Unit 1, Unit 2, Unit 3, and Unit 4. So let me give you the invite link for this. So that's the invite link to create your repo that we're going to work on now. So just as previous, you'll follow that. You should already have picked your name. So you should see a link like this, says accept the assignment, Android Labs 1. Does everybody see that after clicking the link? Okay, so you're going to click accept the assignment, and that's going to go ahead and get your repo started for this unit. And as you can see, it says refresh the page, potentially see updates. So once that's created, you'll have a page like that. You'll follow the link and you'll get here. Okay. Now, does everybody remember how to get this onto your local computer?
I do not.
What do you need to click on? Hit. It's a big green button.
Probably code.
Probably code. Okay, so let's click on code. Now, what do I want to click from here? Do I want to click this up here? Do I clone it, or do I want to download it? Download it or clone it? So the answer is you always clone it. Okay, so we always want to clone it, and the reason being, if we clone it, then we can push up changes to it. If we just download it, we can't push changes to it. So you're going to copy the path here. So that's on my clipboard now. And I'm going to go to where I'm going to fold that down and pull it there. Okay, so let's see. I'm going to go to my projects folder. I would create a folder for unit 1.
If you're trying to show us, we can't see because you're still on the Google.
Okay, so I'm going to switch that over now. Yep, screen, change window. Okay, so you should see the folder here. So we're going to copy that clone link. You're going to then go right click where you want to pull it down, which for me is going to be at this unit 1. And then I'm going to go clone, right click and go clone. So get clone, it'll already be in there. We'll also have that name in there. So for me, that's Android Labs 01, Paul Smith KC. You'll have your specific username in there for Git. So you want to pull that down. And take a look at everybody's process. Okay. So Daniel, you'll still need to click on that link. Jonathan, I don't know if, yeah, so you're at Mo, so please
Click on this link. I got it right there.
Yeah, click on the invite link, follow through that.
Accept.
So once you get that pulled down, does everybody see my screen? You should have a similar thing on your computer. See that?
I do not. I think I'm still having issues.
Okay.
Mine's saying you've accepted or configuring your repository now. This may take a few minutes to complete. Refresh the page. This page to see update.
Okay.
Did you,
Flag out. Oh no.
Yeah, I got it.
did you want us to put that in a specific folder like you had it?
So you'll put it alongside, you basically put it alongside your other repo. So you're going to have one that we created previously, which is going to be unit 0. Should look something like this. And this will now be unit 1. Does that follow?
I might have just done unit 1 wrong because I just put it on my desktop then.
Okay, that's fine. If it's wherever you put it is really up to you. The one thing you don't want to do is put it inside of your other repo. You don't want to put repo inside of a repo. Does that make sense? Your unit 0 repo is, but not inside of it.
This is kind of a confusing file structure. I thought we were going to have it like last semester.
Sorry. One reason for the split is that you need a different getignore file for Android Studio versus IntelliJ. So if you try to put both IntelliJ and Android Studio projects in the same repo, it doesn't work real well. Also just trying to constrain the number of folders and such that are in there. Okay. Does everybody see my screen?
Yep.
Okay. So what you'll see in here, once you pull down the repo for Unit 1, you should see a bunch of folders labeled like 1.1, 1.2, 1.3, 1.4. Any guesses as to what you're going to put in there?
Each project.
Each project, right? So we're going to put our stuff today into 1.1. Tomorrow we'll put into 1.2. On Thursday we'll put into 1.3 because we're working on those lessons. So lesson 1.1, 1.2, 1.3, 1.4, etc. Okay. So it'll kind of, as we go through the code labs, it'll give us kind of names to give those projects. But this will help keep things straight as to where it is, as well as what version it is, because some of the labs do build on each other. So that way I can go back and see the version of the project that you had for that particular lesson. So there are some of these projects that will start in one lesson and continue on in later, so we'll need to make a copy of it. Okay, so now that we've got that pulled down, we can actually pull up the lab. Okay. And remember, I did link this up earlier today, this link to the Training Fundamentals TOC Volume 2, Version 2. And if you look on Inside Ranken, you'll find a link there to it as well, if you just go into the Code Lab assignment. So everybody see that link there? It's in Discord as well. Okay. So I want you to pull that up because we're actually going to look at the labs together. Okay, so you follow that link, you're going to come to this page. Okay, so you see there's a link for each of the lessons, right? So you'll notice that there's no code lab for 1.0 because 1.0 is just theory. Okay, so 1.1 is what we're going to do today. Okay, and then tomorrow we'll come back in here and we'll do 1.2a and 1.2b. So this is where we're going to be today. Everybody got the lesson pulled up?
I'm getting there.
Okay. As they mention here, the term code lab and practical, they use interchangeably. So anytime we're talking about practical or code lab, those are the same two things. So the first page, welcome, will give you kind of an intro to what we're going to do here. So we'll go, we've already installed Android Studio. We'll talk a little bit about the Android development environment, the IDE, how to create and run an Android app, as well as how to work with an emulator in a physical device. As far as things you'll need there, what we'll learn. So we'll go over that. We kind of how to install and use the Android Studio IDE, how to use the development process for building Android apps, how to create an Android project from a template, and how to use log messages for debugging, which will be really, really helpful. So those are the bits that we'll go with. So I'm going to jump down to step 2 over here. You can kind of see the steps as we work through, starting from step 1, going down to 14. So in step 2, they're going to give us this app overview, which you'll see with most of the labs. They'll kind of give you an overview of what we're going to be building in this particular lab. And for this one, it's not hard. We're building Hello World. That's it. That's the main objective for today. We're not going very far. That's it. So Hello World is just going to be with one screen, and we'll add some logging to it to kind of learn how that works. The main goal today is to just get your emulators and your virtual devices working and make sure you can actually run apps on them. Okay, so that's where we're going. So installing Android Studio, we've covered that already. I think everybody made it through the install instructions for Android Studio, so I'm not worried about that. So let's go actually create the app. Okay, and this is one we're now on step 4. Fair forewarning, a lot of things have changed in the past few years to this step 4. So the instructions that they give you here, kind of the order of things that occur, is quite different than what we're going to see here in a minute. So you'll just need to know that going forward. Okay, the where things are is going to be a little bit different for setting up projects than where it shows in some of these screenshots. Everybody with me?
Yeah.
Okay, so go ahead and open up Android Studio. It may take a minute or two to You'll also notice powered by IntelliJ platform. Okay. So we want to actually create a new project. You probably won't see any projects here on the left as of yet. Those are projects that I've already created. So we need to create a new project. And so to start a new project, you just click create new project. So we'll get into here. So the first thing it's going to ask us for is what template do we want to use. This used to be in a different order. This used to not be the first question that it asks, and is one of those differences. But for all of the assignments right now, you're going to start with empty activity. Later in Unit 2, we will start using basic activity as our kind of our default go-to, because there's a few things in there that you want pretty much all the time. But we're not going to cover those right now. Okay, so we're going to start with empty activity as the way you're going to start any labs that you create for the foreseeable future. Everybody with me?
Yep.
So that empty activity is going to basically start with not much in it. It's going to give us an activity class, which is going to represent the backend code. It will also give us an XML file, which, as its name implies, will be basically empty. So we'll put our own content into that. Okay, so we're going to start with empty activity. We need to now name the application. And if we look at the description in here, what are they calling the project? Well, it looks to me that they are calling the project Hello World. See that? So that is the name of our application. Now, when we name our application, you'll notice that here in this first field, it's okay to put spaces in. And we typically will, right? So up here, you can say that it says Hello World in that first field. Now, notice what I have in my second field as the package name. You will likely have something different, which you'll want to go ahead and change. So just like we did with our Java projects, we're typically going to start those with edu.ranken.your student name. That's the way that we're going to disambiguate your app from somebody else's app, because as it turns out, every app in Android really needs to have its own unique name. So that's how you're going to put that in there, and then that's going to be terminated here finally with the name of the project. Okay. It's worth noting that this identifier here does have to be a valid package name in Android in Java, which means that, for instance, you can't put spaces in there. Spaces are not supported in package names. You can put underscores, but you also notice that it's all lowercase. The convention with Java packages is that those are always lowercase, because an uppercase letter would indicate that it's a class. Okay? So you should have there your package name there is edu.ranken. Your specific name dot hello world. So that might be like Muhammad underscore Kadik, or that might be Corey underscore Ferguson. That's what you're going to put in there. Everybody got that?
Yup.
Okay. The next thing what you want to do is set the save location. And just like we, with the IntelliJ projects that we created, this one's can be easy to screw up. So do pay attention to where you're putting it. The first thing you want to do is go into your repo that you just pulled down. Okay. And then under there, we're going to go into 1.1. So you're going to select 1.1. Now you'll notice at the end of this folder, what does it end with? Does it end with hello world?
No.
It does not. And that's important. Because if you put it right here, it will try to turn that 1.1 project, 1.1 folder into an Android project. You do not want to do that. Okay. And if you do that, then your assignment's not going to get graded. I'll have some issues with that. So please make sure that save location always ends in the name of the project. Now typically that name of the project, we won't include spaces. But typically we will follow, we do follow the same capitalization that we have up here. Yes, technically you can put spaces in there and that would be okay, but the general convention is that you pull the spaces out. Does that make sense? So we're in 1.1 / hello world. That's the important part. Questions so far?
No.
Okay. You'll set the language to Java. There's another option called Kotlin. That's a different language and that you can use to build Android apps. We won't be going over that this semester. You'll notice that there's a minimum SDK. This is where you're going to set it to 21. And that's what it's going to be for the entire semester.
Lollipop.
21. Lollipop. Yeah. So that's what you want to remember to put there. If you're looking at the specific code labs and you're following the instructions, what version are they telling you to put there?
4.0.3.
Or API 15, right? So the instructions on the code labs, they will say 15. All of these code labs will say 15. I want you to do 21 instead. Okay? If you started as 15, you'll then need to change the project and upgrade it to 21.
My Android Studio just closed out on me. That's weird. Oh, it's making me
that's what we're
read
going to do there. You'll notice that there is a checkbox here that says use legacy Android support libraries. Do you see that on the bottom?
Yeah.
So that is the old support libraries. We do not want to check that. By unchecking that, it's going to use the newer support libraries, which are known as Jetpack. So Jetpack is used to nowadays to support older versions of Android, and that replaces the old Android.support libraries. So for all of the labs we do, we will not have that checked. It's worth noting, you'll know that there's a little link here, help me choose. That will bring up a chart here so you can see kind of the distribution of the different version numbers, the current distribution, as well as what is included in those different levels, so you can have some idea of what you're targeting. So that can be very helpful if you're needing to choose your minimum. But for this class, all of our applications will have a minimum of 20. Okay, so let's hit finish now that all of those things are.
Mr. Smith, since I might just close out on me, so I just wanted to reconfirm when we're doing our full name. It's like, for example, mine would be Muhammad _ Kadik or dash Kadik.
Underscore.
Okay, cool.
Yeah. So that may take a few minutes to load. You want to make sure that you don't click on anything on it as it's loading. It may crash. That would be a problem. You may have to, if it crashes during this setup, you may have to delete the project and start over. So I definitely let it give it enough time to finish doing all the things it needs to do. So there's a Gradle build. You can kind of see that spinning down at the bottom of my screen. Gradle sync started. There's kind of this progress bar here. Anytime you're trying to see what it's doing, you can click on that and you can see background processes that are running. So until that completes, we can't really do anything with Android Studio.
Mr. Smith,
Yep.
What was the language in the minimum SDK again?
The language will always be Java, and the minimum SDK is 21.
Okay, thank you.
So once that finally pulls down, you should see something like this in front of you, and you'll notice that my package name is up there at the top of the file. So when you get the project created, please thumbs up on the post on Discord so I know that people are ready.
Are we just waiting now?
I put look in Discord. Look in the general chat.
Oh, okay. I didn't see that.
Yep, I'm just waiting for everybody to be ready. Okay. All right, so let's move on to the next thing. So you'll see two files are open initially when you create the projects. So you'll see that there's a Java file that's open, and that's going to be where we put the main part of our Java code. You'll also see that there's an XML file open, and I can click on that, And that's where we're going to actually design the UI of our application. Okay, so the XML is going to be where we design the UI. The Java file is where we're going to design and implement what the application actually does. Okay, the actual functionality. Okay, so you always have those two paired together. Anytime you have an activity, you also have a layout file that goes with it. In some cases, especially as we get later on, when we start creating things with the basic activity, you'll see that there's more than one layout for each activity because of how that works out. But that's how we're going to work here. Now, I have a pop-up here that says project files can be added to Git. Does everybody have that? Is everybody seeing that?
Yep.
Mine's loading.
Okay.
Where did you just? I lost you after you did the activity. Oh, the XML.
Yeah, I'm on the XML file.
And then we're looking at what?
There's a pop-up that showed up here.
No, mine doesn't have that.
Project files can be added again. Okay, if you do see that pop up, go ahead and hit always add.
The only thing I have is something about the daemon.
That's fine. You may or may not see that come up, but if you do see that come up, just say always add. Okay, so we've got those two files there, and that's the kind of the start or the skeleton of our application. Okay, so let's talk a little bit about some of the windows and things that are available. So this is the main kind of code window. This is where we're going to write our code. This is what's referred to as the layout designer. Okay, we'll talk more about the layout designer this week and next, and how to use that. So the next thing I want to show you down at the bottom, you'll find that you have a bunch of different tabs. You'll see that you have one for Git. You'll see that you have one for the build and a terminal. The most interesting one, and the one you'll probably want to keep open, is this one called Log. Does everybody have Logcat at the bottom of their screen?
Yep.
So this is where you're going to see log messages coming from the device that you have either plugged in or the emulator that you're running. So you'll be able to write your own messages out to them and search for them and kind of see. That's the main thing that you're going to use to debug your applications, to see what's going on, what sequence did things happen in, and fix problems.
It's like Morgan.
Yeah, it's or your debug module. Remember, we used the debug module a lot, the debug package in Node to write messages out to the terminal. So this is the same kind of thing. Now you'll notice that I'm connected right now to my physical device. There's already a lot of noise coming out of here, even though I'm not doing anything. That's pretty normal. Okay, so if you see a lot of messages scrolling through, don't be alarmed. That is what it is, but it does mean that we always have to filter down to the messages that we're interested in, because all of these messages here, I'm not really interested in. Okay?
Is this supposed to be the tablet?
This will be the tablet. If you have the tablet plugged in, you might see something like this already. If you don't have the tablet plugged in, this will probably not be doing anything yet. So let's say I unplug. If I unplug the tablet, you'll see it stop scrolling, and you see it says disconnected. Everybody see that?
Yeah.
Okay.
I was just making sure. I was like, this is supposed to be the tablet, right? So.
Plug the tablet back in. Okay. So this is your main code window. That's where you're going to kind of see your terminal area. That's where you're going to see your logcat messages. The next thing we'll do is we'll look over here on the left, and you'll see what we call the project area. Everybody see that? And you'll see a few folders are already expanded. Now let me expand it a little bit further so we can look at what's there. So you'll see first up top, this word app, all in bold. That's all of your application code. Okay, so that includes both your Java code and all your resources, and your XML files are going to be under this app folder. You'll also notice that there's a drop down here labeled Android. Everybody see that? If you change that, you're going to get a different view of the files here. So Android is typically the one you're going to want to be in and stay in. If you were to switch to some of these other ones, say project files, what that's going to give me, it's going to show me how the files actually are on my computer, because you'll notice it's not exactly the same if you go to, say, File Explorer. So if you go to Projects Files, you'll see it exactly as it exists on your computer. So for instance, you'll see that I've got under Source, I've got App and Source. Source is where the main part of my code is. Under there, I have their main is the one I'm interested in. Java, edu, Ranken, PR Smith, Hello World, main activity. So you can see each of these parts that are in the package name separated by a dot are actually separate folders on your computer. Does everybody see that?
Yep.
So one of the things that means, and also if you pay attention to, we'll see the layout files more as we go on in the semester. You'll see that the layout files also, the resource files have a different structure than what it shows in the Android package. So the way that the files are laid out is not how you're going to see them in the project pane. And that is worth noting, because sometimes you do need to look at it in the way that the files are structured. Most of the time it's okay to look at it in the Android structure, but do be forewarned that there is a difference. So for instance, you'll see here that there's a drawable and a drawable -v24. Does everybody see that there?
Yeah.
If I go back to the Android view, notice that there's only one drawable folder, okay? But it labels this, you see a little parentheses here? v24. So these two files look like they're in the same folder. They're actually in two different folders. Got it?
Yeah. Regarding the pop-up that was on the bottom right,
Yep.
project configuration possibly had to get always add.
Always add. Yeah.
Is there a way to
Always add.
change that? Because every time I would create something in IntelliJ, it would ask me that, and I always clicked always add. It seems like a setting you'd always want.
It should go away once you've hit always add, I believe.
For that one, and then you create another one, and it keeps asking. You know,
Okay.
we did 20 projects for our homework, so it just came up a lot. I figured it was a setting to be changed.
Yeah, there's got to be a setting for it. Offhand, I'd have to go look for where that is. Anyway, so that's kind of the difference in structure. Typically, when you start opening the project before the Gradle finishes loading, it will usually show it in this project version. You see project here, which again is kind of similar to files in the sense that it's not going to show it in the same way that the Android view shows up. So if you see here up on the top, that's an indication of one of two things. Either your project is still in the process of loading, or it did not load successfully. So if you see it as project, you're not going to be able to run your application. There's going to be a problem with your files. So that usually means that there's some file that's missing that you didn't get checked in. Cool. So do pay attention to that. That should say Android there. Okay, so the general structure here, as we can see, I'm going to kind of collapse these folders. Like that. So on the top, we've got app. App is split up into a few different categories. So we've got, on top, we've got manifests. And as he mentioned, this is kind of the, tells Android what files are actually in your application. And it's actually the first file that Android runs. So this will include things like what activities you have, what broadcast receivers you have, what services. So that's going to include all of that information, as well as things like the launcher icon and actually the name of the application. Next down here under Java is where we're going to put most of our code. You'll see the first package. This is where we're going to put the main part of our code. It's called main. But you'll also see that there's an Android test folder and a test folder. Do you see those two here? Now,
yes.
we won't do much with those this semester, and I think I'm going to skip over the labs for those. The test folder is specifically for writing unit tests. Android tests is for writing automated UI tests. So those are covered in later lessons, but we won't really do too much with those because they don't tie in with the rest of the course. But that's why they're there. Most of the time you can just delete these two. Most of the time you can safely just delete those two folders. Next, res is short for resources. So under res, we're going to put a lot of different kinds of resources. So they're grouped into what kind of resources are contained in there. So first of all, you've got drawable. So that's things like images, pictures. That's where we're going to put anything that can be drawn on screen. Layouts is where we're going to put layouts for the individual activities for each screen. So you can see there's one layout in there. These two drawables are for the launcher icon. Map is also generally used for the launcher icon. It also contains images. So images sometimes go into drawable, sometimes they go into map. The rules behind that I won't really get into, but just know that there are images in both of those two places. Finally, you'll see that there's a place called values, and that's where we put a lot of different tidbits of information. So for instance, you'll see that there's one called colors, and that defines the different colors that we're going to use in our application as constants. You'll see there's one for strings, and this one we'll spend a lot of time with because this one's really important for translations. So if you want to say make your application available in 3 different languages, this is the key to make that happen, is to put your text of your application in strings.xml. And then finally, you'll see there's a folder for themes, and that has to do with styling your application. So the default application, we started from not basic activity, from empty activity, has already created 2 themes, and one of those is a light theme, and one of those is a dark theme, which is a new thing in, I believe, Android 10 that was added as an operating system wide thing, where you can say every app on your application has a different theme at night than it has at day. So we'll get to, Corey, you're asking about setting the tablet up. We'll get to that in a minute. I want to just kind of go over where things are at here, but before we do, the next 2 things we want to do is just get your emulator set up and your tablets, and we'll get this application actually running on your device. Okay, but that gives you kind of an overview of what those files are. The last file I want to mention here, let me actually reopen the layout and the main activity. Going down here, you'll see there's a few different Gradle files. The only ones we really care about under Gradle scripts are the top 2. So the first one is project level, and the only setting that you really care about in here is this one right here on line 8. Does everybody see line 8? And the part of that matters is this version right here, 4.1.1. Does that sound familiar?
Shouldn't that correspond to the Android version? We're supposed to be using Lollipop, right? That's the KitKat version.
That is the version of Android Studio. So the version of Android Studio that you're running is here. Okay. So to be able to open it up and have it behave like a 4.1.1 project, that needs to say 4.1.1. If you go to update Android Studio, that number will change. With me? So if you had like Android Studio 4.2, this would show as 4.2. Okay, so if you do get in a case where you're running the wrong version of Android Studio, you're going to have to go in every project and change that to 4011. Okay, so that's the one setting, that's the only setting we will ever touch in this semester, is that one. The next one, which is the module level, this is the one we will do a little bit more with. So there's a few things to pay attention to here. You'll see there's compile SDK version here. That for me is saying 30. You'll also know the TARDIS SDK version for me is saying 30. For you, is that saying version 30 or version 29?
Mine is 30.
Anybody on 29 there?
Mine is 30.
Okay. So these two versions, they both actually need to be the same thing. I really wish that there weren't two settings for both of them. But that is the maximum version that your app can support. So your app can support up to version 30, okay? And that's important. So for the things we're going to do this semester, that needs to be 29 or 30, and it sounds like for everybody that'll be 30. Next up in here, you'll see that says minimum SDK 21. So if we do need to come back in and change that, maybe you accidentally created the project as SDK 15, that's where we would go in and change that to 21. You'll also notice in here is the name of the package, ED Ranken PR Smith. So say you want to copy and duplicate the project, make a new version, which some of the labs ask you to do. This is one of the things you'll need to go in and change if you need to fix your package name. Cool. You'll also notice that there's two options here under compile options. It says Java version 1.8. What that does is it enables us to use Java 7 and Java 8 features in our Android applications. If these are not present, then you're basically stuck with Java 5. Cool. And then finally, you'll see dependencies. These are things that we're, libraries and other things that we're depending on their application requires. And again, we'll talk more about that in the coming weeks. So that's kind of your overlay. The build Gradle is really important in how your project builds, and it contains all of those really important version numbers. So now that we've got that sorted out, what we want to do is actually get this running on an emulator. So if you go up to the top, and you should see a drop down called Tools. Does everybody see Tools?
Yep.
Under Tools, you're going to see AVD Managers right above SDK Manager. Okay, so click on AVD Manager. More than likely, you will probably not have anything listed here. Is there anybody that does have a device listed here?
Yes, I do.
I do.
Okay. If you do have a device listed here, what you want to do is actually delete them. Any device you have there, please go ahead and go to the drop down over here, and you're going to hit delete. Depending on the options you picked when you installed Android Studio, it may have created them, it may have not, but please go ahead and delete those if you have them already. Once you get those deleted, please let me know so that we can move on with everybody at the same place.
Deleted.
Deleted.
Cool. Okay. So what we're going to now do, you'll see that I already have some created.
Wait, so Mr. Smith, even delete the ones that came with
Yes.
Okay.
Yeah, delete all the ones that came with Android Studio. So these are the ones that we're gonna create. I'm gonna take a screenshot, throw it in Discord so people have a reference to. That way you're going to have a few different emulators to work with this semester. Okay, so let's create the first one. So what you want to do once this is cleaned out, you're going to say create virtual device. When you come into here, it's going to ask you, first of all, what kind of device are you building? What is the size? What is basically the screen dimensions and the screen resolution that we are going to create. Okay, so they've got a bunch of standard sizes in here that you can pick from. So you'll notice that by default it picked the phone section. You can also find tablets under the tablet section. But the first one we're going to create is going to be a phone. Okay, so go under phone, and you're going to look for a device called the Nexus S. Okay, now the reason we're using this one is because it's got a 4-inch screen. It's one of the smallest ones available. And you'll also notice that it has a pretty small screen resolution, 480 by 800. Everybody see that?
Yep.
What that means is that this emulator is actually one of the least resource intensive emulators. So both because you want to target generally the smallest screen size to start with, and it doesn't use a lot of resources, this is the one I would recommend you do most of your testing against. Okay? So we're going to create the Nexus S, and then we're going to hit Next. Okay, so then you're going to get to this screen with different system images available. Now you'll notice that most of these have the download button on them. Do you see that the one that I have here, 28, does not have a download button on it?
No, mine's R that doesn't have a download button.
Okay. Well, so the ones that don't have a download button, those are ones you already downloaded. Okay. So what you want to do, I think that, I guess we're targeting version, if we're targeting version 30 here, I should probably download R. So I'm going to go and hit download on that. So let's all get version 30, API 30, which should be R. So that'll take a second to download. If you do have an AMD chip and not an Intel chip, you will probably see something slightly different there. So does anybody see something in here that doesn't say x86? Anybody seeing something different in x86 there? Does anybody know that they have an AMD chip?
Like an AMD like GPU or something?
CPU.
Yeah, no, I don't have one.
Okay.
I have Intel.
If you have an AMD chip, you may end up needing to pick a different image. It will hopefully already recommend it, but there's a different image that you have to pick for AMD processors. So this may take some time, as it said this is about 1.2 gigs.
Break till 3.
Let's let this go because I want to show you where to get the next image before we break here.
It was just R, right?
Just R from that screen. One of the things you'll notice on the screen, notice that the highest version is 30, but the lowest version is 22. Everybody see that? Highest version is 30, lowest version is 22. So if you want to if you want to test your application against API 21, which would be Lollipop, you actually need to get a different image that's not shown here. Do you see that? So API 21 is not shown here. Okay. Everybody following with me? Watching my screen?
Yeah.
Okay. So what you're going to need to do, you'll see that there's 3 tabs on top. So recommended are just the ones that Android or Google recommends you use. If you go to x86, that will give you all of the x86 based systems. But you'll also notice that there's a bunch of extras, right? So here under Q, there's actually 3 different versions. There's an x86, 2 x64s, but notice one of these has the Google APIs, and these other 2 do not. Okay, so that's one place you can get to it. You can go to x86 images. That if you do for whatever reason need to get to the ARM APIs, which for instance you may need to use to work with an AMD processor, then you would go over to other images. So other images will show you all of the images, especially the older ones. But the way I believe I can find it in API 20. Yeah, it's x86. So what you're going to do is go to x86 images. You're going to go down to API 21, and here's the one you want to install. API 21, x86, Android 5.0 with Google APIs. So those are the 2 images you need to download. Is API 30 and API 21.
What?
It's the first one under 21, right? I looked away for a second.
It
So-
is not necessarily the first one under 21. Let me be really clear about that. It is not necessarily the first. It is first on my screen. It is not necessarily the first.
Yeah, so just the x86 one, but there's 2 x86 ones.
It's x86, Android
Google
5.0, Google APIs.
Okay.
It needs to match that exactly. You want that version. And again, it probably will not be the first thing on the list. It may or may not be. So that's about a gig. So that will take a few minutes. So now go ahead and get both of those 2 downloads started, both the API 30, API 21. We'll take a few minute break and come back at, let's say, 3:20. And hopefully everybody will have those downloaded by then. Cool. Correct, Corey. So if you've already got API 30 downloaded, then you just need that 21. So those are the 2 images that we'll use for all of our your emulators. It's just those 2 images.
I would assume the 64 version is 64-bit. Is there a reason why we don't use that?
Because it's not as straightforward. It actually doesn't work as well as the x86 one. Has been my experience. It's not as stable.
I would think in the real world we use 64-bit though.
It's actually the reverse. Notice that under recommended, I have a 64-bit processor in this. It actually recommends using the x86. Some of these, unfortunately, some of those images have issues running. And the 64-bit ones, I've had a lot of issues where they crashed or ran very slow by comparison. So that's why Google doesn't recommend using them. I believe the x64 ones are actually correctly labeled as AMD, because as I understand it, the x64 ones run, the 64-bit ones run better on AMD chips than they run on Intel chips. That was kind of my understanding. If that helps. But yes, that would have been my intuition, is to use the 64-bit ones, but that's not been my experience that works well.
Seems like a lot of software is still written in 32-bit these days.
Not really. I would say that there's very little, if any, that's written in 32-bit. This is just kind of a weird case because you're talking about an emulator.
Yeah, that makes sense.
So, most if you're writing things in interpreted language such as JavaScript or Python, which are kind of the two most popular languages, you actually don't care about 32-bit versus 64-bit because you don't target one or the other. So the people that care really about the difference between 32 and 64 is if you're writing C or C++ code. Then you really have to care because there's some significant differences between those two. But other than, if you're writing most other languages, even including writing Java, you don't really care about it because your code in Java will run the same on a 64-bit processor as a 32-bit processor.
Yeah, I've run into some issues with the past where I've had to force 64-bit compiling because I ran out of RAM.
Yes.
In 32-bit.
Yeah, well, the upper limit for a 32-bit program is that it can't use any more than 4 gigs. And usually the upper limit is somewhere around 2 gigs of memory for a 32-bit process. So yeah, if you want to get more than 2 gigs of memory, then you may need to do some finagling. If you're talking about an Android application, if you're using more than 2 gig, if you're using anywhere near 2 gigs or more, you have a problem.
Yeah, that's some phones only have 2 gigabytes, I bet. So
yes, that 2 gigs is a lot in terms of phones. There are phones where that can run more than that, but the reality is one app that is taking up 2 gigs is a lot, and the only places where that's usually excusable would be some 3D games. So, general good citizen, to be considerate of all the other apps that are running on your phone is, yeah, you should be sticking under 2 gig, and then it's not an issue whether it's 64-bit or 32-bit.
My download finished. What should I do now?
Wait till 320 because I think other people.
Oh yeah, I forgot you said that. My bad. I was listening to music in the background while this was downloading because I know you said take a break.
Yeah, not everybody has the same connection speed, so give it a.
Yeah, we just got fiber installed in our area, and it's crazy.
Mm-hmm.
What kind of internet speeds you got, Mr. Smith?
I'm on cable, so Spectrum speeds.
Oh, so in my house, they didn't install enough Ethernet cables around our house, but in each room we have coax.
That would be cable.
Yeah. Oh, so you know what I'm talking about. So
coax and cable are the same thing.
Yeah, I bought this little adapter thing that connects to coax, and all our coax cables go downstairs to the main room, where all of our internet stuff is. And you basically plug in this like coax adapter, which converts it over to Ethernet, and then transmits an Ethernet connection.
Mhm.
It's crazy. I never knew about that.
Do you know the original Ethernet standard was on coax?
No, that's why I was like, whoa, you can use coax for Ethernet? Crazy.
Well, yeah, the other the original Ethernet standard was quite different in a lot of ways. Yes, it used coax cables, but yeah. It was also the original Ethernet standard was one where everybody was talking on the same wire. And so all the devices had to kind of figure out, who was talking and not to try to shout over each other. So if you had one malfunctioning device, then all the rest of the devices couldn't use the network.
Get ready for a packet storm.
Well, that wasn't even packets necessarily then. It was a little, I don't know that some of that may have not been packets, because the other thing is coax, I believe, is not digital. I think coax is analog. So, yeah, the original Ethernet standard with coax was before we had really packets and packet switching, at least ironed out. So more electrical storm and less packet storm.
Internet is so cool. I don't know.
Okay, so we're going to continue here right in 2 minutes, and I'll go on and finish creating these emulators. Once we get the emulators up and running, then we can try to run it onto a physical device.
Remember when dial-up internet was a thing? Oh Lord, that was horrible.
I remember using that for a brief period of my life.
I remember using that for a good period of my life.
I remember trying to play Club Penguin back when I was like 8, and like 6 or 7, and it would literally be like 20 minutes for it to load. It was crazy. It was cool though.
Okay, just checking, is anybody still downloading? And take that as a no. Okay, so let's finish getting these emulators set up. So you remember on the previous screen, we picked the Nexus S, okay? And we're going to go here on the second screen, and we're going to pick API 21. So does everybody have API 21 picked?
Yeah.
So I'm going to go Nexus S, API 21. I'm going to hit next. You'll get to this screen, and here we'll let you give a name to that device. So it should look something like this, Nexus S API 21. It also gives you some options to change some of these things here. So for instance, if you want to, by default, to start the emulator in landscape, you can change that here. But we're going to leave that as portrait because that's typically how your user phone is usually in portrait. Okay, so you should have this. Does anybody have anything different showing up on their screen? Okay, so Nexus S. Yep.
We're starting with R first, right? Or are we doing
You can actually do it in either order. We're going to create both. So you're going to create a Nexus S API 21, and you're also going to create a Nexus S API 30. So you're going when you get that all set up, you're going to click Finish here. I can't click Finish because I already have that. So you'll do that for each of those. So I'm going to create another one that will also be Nexus S, but this one I'll run on API 30. So Nexus S API 30, hit Finish. So you should have a Nexus S that's API 21 and a Nexus S that's API 30. Does everybody have both of those?
Only one of them came up for me. I got the 21.
Mm-hmm. So you'll need to go back in and create virtual device again. Pick Nexus S. Pick API 30.
Ah, right. Okay. Yeah. Okay, done.
So you should have both of those now.
Interesting that the API, the newer one, is significantly smaller than the old one.
Mm-hmm. Yeah, interesting thing. Now, that doesn't mean that necessarily it's going to stay that size, because one of the things that happens is once you run it the first time, it's actually going to unpack a little bit. So it'll probably go up in size as soon as I run it. Okay. So I'm going to pick Nexus S API 21. You can see that there's a green button over here, the green play button. So that's how you're going to start the emulator up. So what you want to do, pick API 21, go ahead and hit run to launch the emulator. You can kind of see a progress bar down at the bottom, so it's slowly starting it up. It generally takes some time. And then you should have, oh yeah, mine's already started up because I was using it previously.
What's reasonable? Oh, okay, I got something now.
Mine started.
Wait, which one did you launch? 21?
I launched 21. So you should, once it finishes booting up, which will take a few minutes, you should get to a screen like this. So once you have that one booted up, you'll also want to boot up 30. So I'm going to boot up both of these side by side.
Mine's throwing an error.
What is the error that it's giving you?
It says that it's already running. If that's not the case, delete the file.
Okay, so give it a minute. It might be in the middle of starting up. Look at the bottom of Android Studio. You might see a progress bar. It generally can easily take a few minutes for it to start up the first time.
How do we see the app, the Hello World app? Mine's fired up now. I got the home screen. Is that
you won't see that yet.
Ah, okay.
Why am I getting spam calls?
What?
So you should be able to get both of your emulators running. They should kind of look like that. You'll notice that they look a bit different because they're running on different versions of Android. So this one's running on 5.0 and this one's running on 10.0. Actually, I think that would be 11.0. So Troy, you're getting an error saying it cannot start. You might want to go, if you're seeing an error that says it can't start, Troy, can you take a look at, it's not build.
But they're very different.
Can you maybe click and see if it shows you anything under the event log here, Troy, about why the emulator didn't start?
Can you hear me now?
Yeah, I can hear you.
It's saying something. Hold on, let me find the message.
Yeah, you can
It
post it in
says
Discord.
E-X is disabled in BIOS.
Can you put it in the Discord? I think I know what that is. That's probably the Haxon, and that's the virtualization thing.
It's because he has an AMD chip.
It's definitely not that.
How do we get ours to go to like the home screen like yours?
What are you seeing instead?
Well, one of them says Android and the other one has the Google sign. Oh, wait, something just popped up on one of them.
It's probably still booting then. It's probably still booting.
I used to own an Android and they weren't this slow. Something seems off with my little phone here.
Yeah, that's fine. Sometimes the emulators are slow. Okay, yes. So what you'll need, Troy, is we'll have to make a change in your BIOS to enable virtualization.
Mr. Smith,
Mm-hmm.
I accidentally clicked the maps and now I'm stuck.
Okay.
I have to reboot it, I'm guessing.
What do you mean you're stuck?
Like whenever I click the home button, it doesn't take me anywhere. And whenever I click back, it's just stuck on sign in.
You might try clicking the square button to get out of there.
I am. It's not working.
Okay. It might just be slow, but yeah, mine's stalled too. It may just be that it's slow. If you do need to reboot the device ever, what you're going to do is go up to, you see there's a power button on the top?
Yep.
That's like pushing the power button itself. So often if you click and hold it down, you'll see this pop up.
Restart.
It looks a little bit different. So if you do need to restart the device, you just go in there and click restart.
Yeah, because mine, like, it was letting me like click the login, but it wasn't letting me do anything else. Like, it wasn't letting me click any of the back arrows.
Is anybody else having trouble getting your emulator started? I know Troy's got an issue. Is anybody else running into a similar issue?
I think mine's having the same maps issue as Mo's.
Okay.
Yeah, I don't even know why I clicked on maps. I was just curious.
I recommend not.
Yeah, same here.
So don't touch maps. Got
Don't
it.
touch maps. Yeah. You can probably drag that off of your home screen. So like pick it up, drag here, and I'm going to remove that icon like so. So bring that up a little bit. Now, one thing you'll probably want to do right away, you'll notice that there's some buttons here to turn the device. Do you see that? So these behave like the kind of turning the device on its side. But you'll notice that the orientation of the screen hasn't changed. You know it hasn't gone into landscape mode? Does everybody see that?
Yeah, because you have to like adjust it in your actions or whenever you installed it. Landscape.
No.
No.
So when these emulators, the default way that they're set up, they don't automatically change. So what you want to do is you want to pull down from the top, and you should have something like this. Does everybody see that? So you see the button labeled auto rotate, and you see how it's grayed out. You need to turn that on.
Sounds like someone's playing video games.
And now my device went crazy.
I can see why you gave us real tablets.
Yeah. So that's one of the things you want to turn on. You want to turn on auto rotate, and then it should be able to automatically change. Although it looks like it's not changing right now. It should change once you get into the app. I think the home page doesn't support landscape.
It's got some serious lag time though.
Mr. Smith, if you go and click Chrome. Oh, don't click Chrome. Don't click Chrome. Yeah, don't click it.
So I'm going to close one of those and just go back to one emulator. Okay, so this is what I have, right? And so basically with those emulators, you see that there's a bunch of different ways that you can set them up. So that way you can have a bunch of different configurations that you can test with, even though you only have one physical device. Does that make sense? So it expands your horizon because there's a lot of devices on the market, and it's not really practical for you to have every device that exists. Everybody with me? So what I want you to do, we created 2 devices already. What I want those 2 phones, Nexus S, I want you to go create 2 tablets, a 7-inch tablet and an 8-inch tablet. So I'm going to delete the 2 tablets I've already created. So I can get them up to API 30.
So it's just the Nexus 7 and the Nexus 9, which is the 8.86.
So let's see, if we go to the Nexus 7, you actually, I think, want the WSVGA. This is the one you want. Because if I remember right, I think this is close to the same dimensions as the tablets you have, is this WSVGA, this generic one, as we say. I think that's closest to the Tab A's, if I remember right. So you want to pick that, WSVGA. We'll go to API 30 for that. And so when I get to this one, though, I'm going to rename it to 7-inch tablet. So it'll be 7-inch tablet API 30. Everybody got that? So that is the WSVGA size. And then we're going to do the same thing for the 10-inch tablet, but that one will be this 10.1 WXGA. So that's roughly equivalent to the Samsung 10-inch tablets.
And we're doing them both on R, right?
Correct. Now, I meant to set those. I want to make sure that these are both starting in both of those tablets. I want to make sure that they're starting in a landscape orientation. So if you ever need to change something, you set something up wrong, you can just click the little pencil button here and edit it and change those things. So I'm going to change those both to landscape, because typically most of the time most people use their tablets in landscape orientation. Now you were saying, Paul, that it started really small, right? Notice at what size it is now that it's actually started.
Oh, yeah, that's like 20 times growth.
Yeah, so it started as half a gig, but once it actually went up and was running, it's now 9 gig. So, yeah. So you want to make sure you start all of those once and get them running.
So this has pretty heavy use of your system, right? I mean, this isn't just a light thing we're doing. This, you should probably close everything down, and
yeah, you're not going to be able to
resource
run.
heavy.
Yeah, Android Studio 1 emulator is about going to be the limit of your system. It's very unlikely that you'll be able to run 2 emulators at the same time.
Oh, I'm running all of them 4 times, baby. Gaming computer.
Yeah, I've got 4 on, but it's slamming my CPU.
And I would not recommend running 2 copies of Android Studio at the same time either.
So, what about? It won't let me run this tablet thing. I got pop up here.
And you want to do the same thing in here once you get that up, and turn on auto rotate for the tablets as well. So one big thing that's worth noting, it takes a long time usually to start the emulators. So usually I'll keep them running as I'm working on something and not close them every time I want to test something. Because otherwise, if you close it every time, then it has to reboot every time you want to run and test your application. So once you get it up and booted, you're usually going to leave that emulator up and running. So any questions on getting those emulators running? I know Troy, you're still having an issue. I'll get with you in a minute.
Why does my 10-inch tablet not look like that?
It may be bigger.
No, it's smaller.
Okay.
I think
that's one of those things. As I said, screen density is something that's really hard to measure here and know what it's actually going to be, because, for instance, this is one screen density, one screen resolution, and that's another screen resolution. Either way, it's the same number of pixels, but it's a different screen resolution, effectively.
Yeah.
Can you change the size of the window? Is that actually changing the size of the screen and inside the emulator?
Effectively, well, the emulator still renders as the same number of pixels horizontally and vertically. It just renders them to a smaller space on your physical screen.
Okay.
So it means that if it's running like this, it's doing just as much work as if it was full size.
I just wanted to make sure resizing it on my screen wasn't going to change anything.
Yeah. It's just you kind of, if you're going to resize it, you have to be careful about measuring or guessing what it's actually going to look at, when you actually run it on a real tablet. It will likely look smaller or bigger than that. So, okay, so I'm going to shut that down, and I'm going to go to just running the the original one that we have here, which is API 21. Okay. Which seems to be, oh, there it goes finally. Okay. So you may need to, every once in a while, you may want to get back into here to look at your emulators. So does everybody remember how you get in there? How do you get that window back open? Where do you need to go?
Tools.
Go Tools, and then where?
AVD Manager.
Good. Because oftentimes you want to come back in here and mess with your emulators and get them up and running. So that's the way I would recommend doing things there. Okay, so I've got one emulator running. Paul, you were saying something?
Yeah, when I try to launch those tablets, whoa, that really was a wallop to my system. It killed Discord, all my other instances of the other the phone simulations, and Explore. I mean, it was like a nuclear bomb to my system. So is that going to be a problem? What's causing that?
The fact is that they use a lot of memory, and what that means is you can't have 100 tabs in Chrome open.
Okay.
It means you're going to have to limit yourself to about 3 tabs in Chrome.
Yeah, with all 4 emulators running, I'm using 20 gigs, so it's a lot.
You're not going to have a lot of space for other things. And I would only recommend having the one
Jonathan.
at a time.
Not Jonathan.
Jonathan's sick.
Yeah, he's out sick. So now that I've got that all set up, the way that you actually use this, let me pull this off to the side. The way you're actually going to run your application is actually pretty simple. You see that there's the run button up top? Same run button you're used to running your other apps with, your console apps. Just hit run, and it will, assuming you have the right device picked here, it will go and run on the emulator. It'll probably take a few minutes, as you can kind of see it spinning right here, because it's got to build it before it can push it down there.
Where's that at?
The run button up here. It's a green arrow. And generally, I would recommend having the emulator running already before you try to run it there. I can directly do that in one fell swoop. So for instance, if I want to run it on the API 31, but that one's not open yet, I can pick that and hit run. It will go and start the emulator and run the application. But I generally recommend having the emulator already up and running, because it'll be faster and less buggy. Because sometimes if the emulator's not running, it bugs out and doesn't actually run your application.
So it's just supposed to shoot over and say hello world.
Yep. So if it's working, you should see it pop up here. Now, in terms of getting things onto your physical devices, so what you want to do is there's kind of one page of instructions of how to do that, of things you'll need to do. Once you have the device successfully configured, what you can do is you can just pick it from this list. So mine is not showing up right now. Unplug and replug. So once the tab is recognized, you should see something like this that shows up. But you'll also notice that it's not really, it's not actually showing up here. So typically when you plug the device in, it would show up there. Let me kill this emulator and see if that fixes it.
So you're just plugging in USB to your computer.
Yeah, so I'm going to plug it into USB. Actually, here I need to turn on my webcam. And of course I can't record my webcam and put it in Discord at the same time. Okay, so I've got to kill my recording and do this, unfortunately. So let's see if I can find that on the emulator. So it's down here on the emulator, but you typically don't need to set it for do all that for you. But again, it's the build number is what you're looking for. Does that answer your question, Corey? Yeah, it's no problem. I believe my instructions were right when I initially, I feel like I checked them this semester and they were fine. And then the tablets upgraded and now they're on, they're no longer on Android version 9. They're on Android version like 10. And I think it moved then. But okay. Any questions on running your device on physical hardware or emulators? Okay, so Troy, you still here? Troy, are you here? Okay, you're typing. Yeah. Okay, cool. Cool. You found it in your BIOS. Awesome. Okay, cool. So I was going to catch up with you right now, but it sounds like you're good. Okay, so you can read through task 2. There's probably some more depth of things we may or may not have touched on, so you can read through that for some more review. We've got our virtual devices up and running, so that's task 3 is down. We got it running on a physical device, so that's down here. So then the next step that we want to go to would be task 5. So this says change the minimum SDK for your app, and this will kind of show you how you can toy with that. So for instance, we'll go and change that. They are changing it from 15 to 17. Let's say we'll change it from 15. We'll change it from 21 to 28. So what you want to do is just kind of we'll play around with that and see what happens as we change the minimum version of Android. So I'm going to go back to Android Studio. I'm going to collapse a lot of this stuff and go into this second Gradle file. Okay, so you'll open up that Gradle file. Now what you'll see in here, you see it says minimum SDK version 21. Does everybody see that? Everybody got this file open?
Yes.
Okay. So I'm going to change this to 28. Now, so far that hasn't had any effect yet. Anytime you change something in the Gradle, you have to actually tell it to update the project, basically. And it's called syncing. So on the top, you probably saw a yellow pop-up. It says Gradle files have changed since last project sync. A project sync may be necessary for the ID to work properly. Does everybody see that on my screen?
Yeah.
So most of the times you'll see that. Sometimes you won't. So if you do see that, you can just click sync now, and that'll fix it. If you don't see that pop up, what you'll want to do is go click this little elephant icon up on the top. Elephant with a little blue arrow. That will sync the project as well. So I'm going to go up here and click the blue elephant. It's the same thing as clicking that one. And then it'll spin a little bit and be done. So now it's changed it so the project, our app, can't run on anything less than API 28. So if I try to run the application now on my emulator, it'll work just fine on this one, because remember this one's API 30. But if I try to go to my other emulator, we'll see that it doesn't work. So for instance, if I go to AVD Manager and let's open up API 21. And we kill this so it's not running. Okay, so it's no longer running the app, and you can always see what's running by just clicking that square. So I'm going to go run it against this one now. And you'll notice already in the dropdown that it shows this. It says min SDK API 28 is greater than API 21. Do you see that? So when I try to click run, it's going to say, oh, I can't do that. Because basically that's the wrong version. Now, the reason that it's actually failing is because it says something about certificates, and that's because things have changed. This app's already installed, so it's getting a different error. So what I actually need to do is uninstall the app first before I can get in there. So I'm going to hold that and go to app info and uninstall it. So now that the app's uninstalled, it should give me a different error when I try to run it. Oh, well, it's the same one. Okay. So you may see that. So that's kind of the reason why we need that to be lower, is otherwise we can't actually run it on older devices. Other things you may see change as you're writing your Java code, it will make recommendations about how you should write your code based on the minimum version. So if you were, for instance, to change the minimum version to 15, it will give you some different recommendations about how to write your code than it will if it's at 21. Okay? Because basically best practices and compatibility rules have kind of changed over time. So I'm going to go back to 21 and hit sync. And I should be able to go back and run this on the device again. So that's kind of what you need to do in order to be able to actually change that. And you will notice in the documentation that it used to have, the sync button used to have a different icon than it does right now. Okay, so last up, let's go to add logging statements to our app. So we looked at the log pane already. And the log pane is where we're going to be able to see the logs from our app. We want to actually put some code into it to be able to write our own logs. So in Android Studio, what we want to do, I'm going to go back to main activity. I can close everything else. I'm going to add some code in here. Now you'll notice that we have a class, right? So a public class main activity extends app compat activity. So you'll see that normally that allows us to operate on older versions of Android. There's a lot of compatibility built into there. You'll also see this method called onCreate. OnCreate is the first method that runs when your application runs. So if you want to run write some code that runs when your application starts up, and just the first time it starts up, basically, then we'll put it into here. So in here, I'm going to add a line to write a log message. So in order to write a message, we start those with log, and then I'm going to say log dot. And there's a few different methods here I can use. And the methods that we care about most are basically they start with one letter, D, E, I, etc. Those are short for the level or the severity of the thing that we're writing out. So for this case, we're just writing debugging information, just trying to see that it's actually doing something. So I'm going to do log-D. Okay, so that says I'm going to write a debug message. So log-D. And now log-D takes two arguments. It takes, first of all, what we call a tag, which will allow us to filter the message. And then the second argument that it needs is the actual message. Now, typically for the tag, what we'll use is the name of the class, right? So what is the name of the class here?
Main activity.
Main activity. Okay, so that's going to be our tag. Technically, it can be anything. As far as Android's concerned, you can put whatever you want there. But the convention is that it's always the name of the class. And I would ask you that you stick to that convention. And put main activity as a string as the first argument. Notice the double quotes. And then we're just going to say hello world as our method. Right? So I've got that line of code in there. Log D, main activity, hello world. So when I start the application, we should see hello world appear in the logs. So let me go ahead and hit start. And watch the logs closely. See if you can see hello world. Did anybody see it?
I didn't.
I didn't either. So notice that there's a scroll bar here. Remember, there's a lot of code written. So the message that we wrote, actually, as it turns out, is not the last one here. So I need to actually scroll up and look for it. Okay, do you see it? You see it on my screen? See how it says D main activity colon?
Oh, okay. I was about to say, would I be lying if I didn't? If I did?
So it's right here. But you'll notice it's kind of buried in all of those log messages, right? So that can be a problem in terms of trying to find what actually is running. Actually, I'm in run. I want to go back to logcat. So back in logcat, let's see if I can find it here. Did it already? Oh, okay. Already disappear?
Mine was kind of up near the top.
Oh, I know why it's not showing up. Notice what device I have here. See the Samsung? it's running off my physical device still. So I need to switch it over to monitoring my emulator here. Do you see that? So the first one you have to change to your appropriate device. And then it switched it already to there. Let me go ahead and just restart it. There we go.
Can we, is it a problem if we are using a physical device? Do we need to use an emulator right now?
No, you can do it either way. It's the same process. It's the same process. I'm just on my emulator here so you can see it.
I got
so
you.
you can either use the tablet or an emulator right now. It's fine. So you just want to make sure you have the right device picked. You'll notice it's automatically switched to the application that we're running. So it's basically monitoring just that application. The next drop down that we have here is determines what level of messages we see. So verbose is anything that's verbose or higher. Debug is debug or higher, etc. So as you change this, we'll change what messages you see. So for instance, if we go to debug, in theory, we would see less messages, but notice what's here. So debug with a D, info with an I, warning, error, all of those are actually higher than debug. So that's why you're still seeing all of those. If I were to go, for instance, to just error, the only thing that I see is error or higher. And you can see how that's a lot less messages, right? So that's kind of important to make sure that when you're logging messages that you log them at the right level. For now, I'm just logging these as debug, and that's okay because that's really appropriate for this. But I probably want to be able to filter that and find those messages pretty quickly, right? I don't want to have to search for the message. So what you can do, remember we put this tag in here. That tag makes the message discoverable, makes it searchable. So what I can do in this little search box here, do you see this? Everybody see my search box? I can type in any words I'm searching for. So for instance, if I type in for hello, that would give me back, in theory, any logs, right? That will give me logs that have hello in it. Okay, so these are all the logs that have hello in it. Anybody notice something? Why am I getting all of these logs? Why am I not just getting this one line?
Because your project name is Hello World.
Because my project name is Hello World. So that means that it's showing me everything still. So oftentimes you need to filter that further.
If you just add a space, I mean.
Right. So if I know the message, I could just type in hello space world and it'll find it. But in general, you usually want to look by the tag. So the way you look by tag is you actually use a special filter. So you use tag colon and then the filter. So tag colon main activity. Usually brings it up. Although I must be missing something. Okay, well maybe that's not working anymore. So usually I type in main activity and that will get me just to the ones for that particular class. Good?
Is regex supposed to be checked for that?
It doesn't really matter in this case. That's, do you want to use regex? Do you not want to use regex? If you're using special characters, then that can matter. Here it's the same thing. So oftentimes you'll want to put that in to make sure you're getting the appropriate messages that you're interested in. Cool?
Yeah, so I got that hello world message, but I also got like 8 other ones that say main activity with it.
Okay. What do they say? Can you put the screenshot of that in Discord?
Yeah, just give me a second.
Because as far as I know, that's the only one that should have come out.
Mr. Smith, whenever you're
Yeah.
doing mobile development, don't you have to like worry of like running too many threads on their phone and stuff like that?
Not usually. Unless you start additional threads, you're only running on one thread.
Okay.
No. What I want you to turn in is this application. So you want to commit this when we're done here, Corey. So we'll turn this in again. Interesting. My my guess, Zach, is that you probably started with a basic activity instead of an empty activity.
I figured out what it is. If you're using the actual device, you get more messages. If you're using an emulator, you just get the
That's
one.
what it is. Okay, because I started with an empty activity.
Yeah. Okay, that would make sense then. All right, so that's kind of how you set that up. A common kind of word of guidance here. We typically don't want to write this tag every time we want to log. So rather than writing this inline, this main activity, we usually want to use a constant. Okay. So remember in Java, the way you declare a constant is static final. So in here, I'm going to go to the top. I'm going to mark it. I'm going to declare it as private static final. Some of these constants will declare as public. Some of them will declare as private. And then the name that we use, some people will say log, some people will say tag. The one I want you to use is log underscore tag. And so what I'm going to do is I'm going to define that tag up at the top of the file. Okay. Oh, I need to specify the type of it because that's why it's complaining at me. I need to say it's a string.
So this makes it easier for us to find our log messages.
Yeah. So there you're just going to say, okay, log tag is that. So then anytime you need to do a log, use that constant. And obviously that constant's going to be different as you add more classes. Cool. The other thing in there, and as I kind of go down here, so that's one way to declare the constant is you can just say private static final is this main activity. The downside of declaring it this way is if I, for instance, want to rename this class, this constant doesn't get changed. But I really want it to reflect the current name of the class. Everybody with me with that? So what we typically declare our tags with is a little bit different. And this is just to make sure that if we rename the class, that the tag gets changed with it. So what you're going to type in first, no quotes, you're going to type in the name of the class. And then dot the class property. So that gives you what we call a class object in Java. Huh?
And then toString.
Yep. And then, well, not toString. What you want to do is call specifically get simple name. And that will give you back the name as this main activity. If you call toString, you'll get something completely different, which is much longer. If you call get name or get canonical name, you'll get the whole package name with it as well. But typically all we want is just the name of the class. So you're going to say the name of the class dot get simple name.
Oh, what does that accomplish that wasn't there before? Because you would need to change that first part main activity if you change the name of the class too, right?
What happens is I can now rename the file. So like, let's say I go to here and I say refactor rename and rename the activity. So let's say I go to test activity or home activity. If I change the name of the class, it will change it everywhere, including that constant.
Okay, it's a find and replace all for that class name.
Because
Okay.
otherwise, oftentimes that gets stale.
That's crazy.
So that's what you want to write there, and that's basically boilerplate. You'll add that at the top of every activity. Okay.
So, Mr. Smith, I have a question. If Google made Android Studio, then why does it look exactly like IntelliJ? Did Google make JetBrains too, or?
So Google and so Android Studio is kind of a collaboration between Google and IntelliJ. It's built on top of IntelliJ.
Yeah, because it looks exactly like it.
Yeah, it looks very, very similar. And again, so it just got a lot in common. So that's what I was saying. Like, yes, we're not going to use IntelliJ anymore the rest of the semester, but a lot of the things that you learn will kind of translate over because they are very, very similar.
I'm surprised they didn't just like add like into the JetBrains, like into their main function. Do you know what I mean? But
it is what it is. So that's that. So that's we can log a message, we can declare that constant. That gives you kind of a start. So the one let's go ahead and commit that here before we get going. So you want to go into Git, or you can go into, I think there was a way to Git on the side, but anyway, down here we're going to go into Git, and we're going to go ahead and commit. We could also do it up top here. We've commit all those changes that we've made. Right. So I'm going to select all of these files. Make sure you click the unversioned files as well. So you'll notice that here I've got a whole lot of other files. If I don't check those, then basically you won't be uploading the entire project.
Yeah, none of that is showing up on mine.
Huh?
None of that is showing up on my Git.
So when you hit Git, that didn't show up. You didn't see a commit button or something.
Yeah, I didn't see a commit button here.
My guess is you probably created the project in the wrong place. Probably created the project in the wrong folder.
Mr. Smith, did I do it right on my Git? If you could check.
I can check in a bit. So that's what you want to do, and then I'm just going to say like hello world here. So that's my comment.
You have to update it so it'll work through the editor, right? It's like an IntelliJ.
Yeah, you'll want to use the same thing. Yeah. Now you may get an error like this that says 3 files contain problems. You see that? Don't worry about that right now. There's some errors that are already in existence on the resource files, and those we'll have to fix later. Don't worry about that. That it says there's warnings. We'll fix
Mr. Smith, I had a crazy question for you. Are we you know how I was asking you that question about like the websites and everything? You told me what. Are we gonna learn Mongo with Android Studio, or are we gonna stick to a SQL?
So my plan is to get into Firebase towards the end of the semester, which is also a NoSQL database.
Yeah, but how are we gonna like, for example, if we make like a, how are we gonna?
Mo, that's as much as I want to say.
We'll
talk about it at the end of the semester. That's many weeks away.
All right, sorry.
Yeah, that's fine. It's a bunny trail. So we committed it, and then we want to push it. Which, why am I not seeing a push button on that tool?
I got the same problem.
Merge incoming.
Get to do a poll first.
Yeah.
I had that problem with IntelliJ, and I had to like, I think it was through you have to add it through the VCS. I'm pretty sure.
Okay. Well, under the settings. Git. So this is the question you were asking about the use credential manager. You want to have that checked. Update method. Oh, I think it's automatically doing the push step.
That's kind of alarming, actually. I wouldn't want that as normal behavior.
Well,
Yeah.
no. Also, Mr. Smith, whenever you click commit and you write your message in, it has like an option where you could commit and push at the bottom. It's like a little drop down. So if you change it, the thing, and then try recommitting it, you'll see.
Okay. So let me see if I go to Tortoisket and see sync if it's got anything. Okay. Yeah, so it didn't actually push it.
Yeah, you got to click commit and push.
Okay.
On the bottom of the commit.
So that's what does it. All right, I'm going to go see if I can pull your stuff down. Here. The last piece, and this is kind of your, obviously check in for a site for attendance. The last thing I want you to do for labs today is to do this challenge. So it's going to ask you to make a happy birthday project and make that under lesson 1.1. Does that make sense? And then we'll hit 1.2 tomorrow. So do the happy birthday project and read up on the theory for today and tomorrow.
It's like anybody's name, or?
Mm-hmm. Yeah, anybody's name for happy birthday.
Sorry, I was looking away. The birthday project, is that right there under the coding challenge?
Yep, it's coding
Somewhere?
challenge, step 9.
Oh, okay, 9. All right, okay.
So that's the last part that you have to do for the labs, and then you just do the reading, and we'll go to 1.2 tomorrow.
All right, pretty easy. It's like a little bit more than Hello World.
Yep.
That's like through the main, like, so what you see, right? Not through the console log. That's the only thing I'm confused by. You want it on the actual console log, or do you want it on the main application?
So what does it say? So it says a common use of log. Yeah. So what I would do both.
Okay.
Have it write it to the log, but also change it to say happy birthday. I think that if you kind of read the chapter and do a little bit of playing around, you'll be able to change the message pretty easy. Notice it's a drag and drop editor, so I'm sure you can figure out somewhere in here to change the message. It's really not that hard. So both. I'd like you to change it here and change it in the right out in the log.
Okay, I think I did that.
You want us to put this in 1.1 or 1.2?
1.1. Yeah, this is still 1.1. We'll do 1.2 tomorrow.
Okay.
Questions? Anybody? Okay. Yeah, I see changes for you, Mo.
Yeah, I just committed that happy birthday one too. So
cool. It's a pretty easy project for today. And most of the projects, 1.1 through 1.4, none of them are really particularly hard, which is why we're just going to do a lesson per day, because it's really not a whole lot of material in this first 4.
Enjoy the break while we can, right?
Yeah, enjoy the break while you can, for sure, because they kind of ramp up. So next week's ones will be a little bit harder than this week. So.
All right, cool. Class dismissed.
Class dismissed.
All right. See y'all tomorrow.
Yeah, no problem. Yeah, to Corey, to answer your question, yeah, I want to create another project. So you'll have your Hello World project, and you'll also have your Happy Birthday project. So there'll be 2 separate apps.
Oh shoot. Okay.
Yeah.
I gotta go fix that one.